This conference will now be recorded.
Ranjan, good morning. Have you arrived?
Yeah, yes, sir.
So guide me to connect.
Yes, sir. Beside the camera, there is a logo for screen. You will see a screen.
Where?
Beside the one, there is mic, camera, and screen. Beside the leave button, there is a button screen.
Screen. Leave.
Screen.
Screen.
Yeah.
So
If you put the cursor there, it will show share screen. So please click on that.
share.
Yes.
Share.
Yes, sir. Then you will get
Share.
two options. One is screen, other is assist. Yes, it's coming.
Where? Your voice is breaking.
Yes, sir. 1 minute. Yes, sir.
How to go to my presentation?
You please open your presentation, sir.
Now I open my presentation.
Yeah.
It is then.
You can open your presentation.
Let me see. Let me see. I'm not able to open my presentation.
You can touch it. The cross button.
I'm not able to go to my presentation.
Where you have stored it? Desktop.
Here in my desktop, but I am not able to.
Please, you touch this screen. There is a cross
One
button.
minute.
Sign in. The sign in screen is cancel.
Oh, so many.
At the top, at the top. Sign in screen. Microsoft sign in screen.
Your voice is very low.
So at the top, sir, at the top. Yes, that one.
Where? Which one? Remote control.
Yeah, this one, sir. The cross button, cross button.
Options.
There is a cross button, sir.
What button?
Cross button. Please cancel this Microsoft sign in screen. You please cancel it.
What I want to do this.
Please click this one. Yeah, this sign in button. Sign in.
Which one? This one.
Yes,
I want
sir.
to microphone. I want to.
Yes, that one.
I'm not.
You can go to the next.
What happened here?
Please cancel this one.
I want to cancel it, but I want to cancel it where?
There is a
And
cross button. Cross button at the top.
not cross button is not appearing now. Here, somewhere it is hiding.
Then you do one thing. Yeah.
Okay, I'm getting it now.
Yeah. Yes.
So unnecessary. Okay. I can see the presentation.
Coming. You can make
You
it.
see the presentation.
Okay.
Hello, Ranjan.
Yes, sir, it's perfect now, sir.
It's perfect. So now I can start.
I'm going to give the
But your voice is very much cracking. Why?
1 minute, sir. 1 minute.
So am I audible now, sir?
Yes, yes. Now it is clear.
Very good morning to one and all. So welcome to this first session of day 3 of the ATAL Academy sponsored faculty development program on recent trends in upstream petroleum technology, organized by the Department of Petroleum Technology, DibrUgarh University. It is my privilege to welcome our esteemed resource person this morning, Sri Ghanagogoi sir, who will be speaking on drilling technology. Sri Ghanagogoi sir is presently working as Resident Chief Asset with MS Orissa Cividors Limited. With 41 years of experience in diverse areas of drilling and production engineering in both onshore and offshore operations, as well as in both in-country and overseas drilling operations, Sri Ghanagogoi sir has retired as Executive Director from Oil India Limited, Noida in 2017, and presently working as Resident Chief Asset with MS Orissa Stevedores Limited, and managing the production operations in 2 fields where the company entered into a production enhancement contract with ONGC for development and enhancement of oil and gas from its discovered fields. A certified petroleum manager with a degree in mechanical engineering, he has developed his skills in all spheres of drilling engineering like directional drilling, horizontal and Z-band drilling, drilling operation risk assessment and mitigation, well design and engineering conforming to regulatory requirement, applications of geomechanics in well design, etc. He has versatile experience in drilling operations in new PSC, RSC regime in overseas countries like Libya, where his sole leadership in drilling operations, Oil India Limited, has successfully completed MWP as assigned with the government of Libya in 2008 to February 2011. He has vast experience in drilling project management under both PSC under NELP and RSC under DSF on onshore and offshore. Under his leadership, he has completed 1 offshore drilling project in Gulf of Mannar in water depth of 500 meters with initial exploration period as per PSC. Sri Ghanagogoi sir is presently heading the production field management of 2 fields in Assam as Resident Chief Asset under PEC for Orissa Stevedores Limited based in Jorhat. Please join me in welcoming Sri Ghanagogoi sir. Over to you, sir.
Okay, thank you, Ranjan. Thank you very much for giving a very nice introduction about me. Welcome to everybody. So this is the actually disadvantage of this online. I cannot see your face and all. Anyway, we have to work in virtual now. So I am welcoming everybody to this session, and I am given this topic to talk on today is the drilling technology in E&P industry as a part of your ATAL Academy for development of your technical persons in future. Anyway, so when I talk about drilling technology on E&P industry, you know the oil, it comes to the oil only. Being a 41 years of having a 41 years of experience in oil and gas in E&P industry, and and related to drilling technology. It is nothing but is related to oil and gas only. So we know what is the price. What is the price of the oil today? It is about 140 barrels. Of course, presently the oil and gas industry has got some negative propaganda due to the carbon emission and all, and due to Paris requirement of 1.2 degree greenhouse effect gas temperature control, and there are many hardships are coming to the E&P industry now. At the same time, E&P industry is going into deeper and deeper problem areas, and also facing deeper and deeper problems and bigger problems, which from all concerns, especially from the environmentalist and regulatory requirements. So when I will be talking about the drilling technology, my mind goes to only to oil and gas. So I'll be speaking mainly drilling technology related to oil and gas. Okay, so let's go. So I'll be talking mostly on this agenda today is the power of optimism. That is the change in energy transition. You know that the oil industry, oil and gas is the most versatile industry, versatile power source. We know it is. You can say this is a mobile power source. You can take oil and gas in any in your tank and go anywhere to any place and utilize it. It is that's why it is called most mobile versatile energy source today. We cannot take electricity as we like everywhere we go, but a small amount. But in big amount, big energy, when big energy is required, is the oil and gas in the energy only. We have to depend on. And mankind, since discovery of oil and gas, mankind is heavily dependent on this source of energy. So, but of late, because of so many environmental regulatory requirements, especially about that 1.2 degree temperature containment to reduce carbon emission, this of late this industry has changed a lot. So there is a negative propaganda about the oil and gas, that it is the main industry that is contributing to the carbon emission, and thereby the global temperature is increasing. So of late we have seen there is a transition in energy. Till I think 2005-10, most of our human civilization, the modern human civilization, is mostly dependent on the oil and gas up to 80%. Up to 80%. So now, of course, of late to 2015 and 2020, we can see that there is a reduction in use of oil and gas. There's a reduction. The other source of energy is increasing now, taking its place. So there is a transition now. So I'll be talking on this transition a little bit. Then I'll go to that India's energy policy 2040 and energy mix. As I say that till 2005-2010, this is the foremost prime source of energy, and this is taking the first bench of the energy sector, oil and gas. So we have that's why this energy policy is being changed now because of 1.2 degree bar, and there is a renewal of energy mix in India now. So I'll be talking about the Indian energy mix a little bit. Then we'll go for the technology and techniques. Then I'll go for the various emergence of various drilling technologies, hint of various offshore drilling technologies, new mud technology like SOBN, various RSS systems. So a growing optimism of fossil fuel. So as I said earlier, that there is a negative propaganda on the oil and gas industry because of that environmental regulations. One important point is that under the Paris Agreement, that 1.2 degree temperature control. So that is the most important thing, that to attain the 1.2 degrees centigrade temperature control and the global temperature, we have to reduce the carbon emission. So that is the one point. That's why this is a negative impact for the oil and gas industry. Then now we know that we are living in a biggest transformation energy industry, which drives the present day industrial, political, and social changes. Late COVID pandemic. We understand that this is the day when people are concerned about their own environment, their global temperature due to change of environmental uh, uh, impacts. People are concerned about carbon emission. People are concerned about oil and gas industry, impact of oil and gas industry. So that's why there is a change of energy trend now. Then we have that strict consensus on reducing the global warming to 1.2 degree centigrade calls for a massive scale up the existing technology in ENP. So that is the power driving point here. Why the ENP technology required for ENP has to be developed to meet this 1.2 degree limit. That is the core point today's will be our today's discussion. How this 1.2 degree limit has effect on the technology development for ENP industry. As we say that this industry, I mean ENP industry or the oil and gas as a source of our energy will be remain there for another maybe one. I do not see any immediate impact, but maybe another 50, 60 years, 50, 100 years definitely. This will be the one of the main source of energy. At least it will be covering the energy mix up to 40%, if not less. Up to 40%, our civilization will be depending on this source of energy. So that is why. So India also now form up a policy for to meet this energy source, to mix the energy, how to meet because we will be depending on our energy all the time. The human civilization has to require energy to carry out its daily activities, also to develop its own requirement, develop its other requirement. So human civilization has to depend on source of energy. It must require various sources of energy, out of which oil and gas is one of the main source. Till 1950, it will be our main source of energy. That is why Indian energy policy is coming up here. So our important reduction, our main thing is this: India is not self-dependent on oil and gas. So we are still today we are importing about 85 to 90%, maybe 80 to 85% oil from outside. So first division is up to 100 to 2040 is to import reduction of fossil fuel by 10% from 2014 to 2015 by 2022. It is already 2022. So our aim was, Dr. India's aim was to reduce the import by 10%. For that, to attain the 10%, what we are going to do and what we have in our energy sector now. So there is one point. So for that, it's a different aggressive policies have been undertaken. Under this reduction, 10% reduction, Government of India, MOPNG has developed several policies like the OLAP, we know, health, DSF, PEC, etc. So now DSF, PEC, OLAP, everything is in place now, and people are working on it to have a reduction of 10% by 2020. But out of this, two policies have come up. One is DSF, other is PEC. DSF is discovered small fields, and other is production enhancement contract. So under these two categories, the fields which were not produced or by the major companies or PSCs like Oil India were given to small companies so that they can bring up production from these fields. so that to compensate that 10% reduction. So I am working in one of the project in PEC now. So another energy requirement, another our policy is that emission reduction by 30 to 35% by 2030 to 2050. This is, I'm sorry, this is 2050, not 2005. I'm sorry for that. I just come to know. This is 2030 to 2050. And achieving 150 gigawatt renewable energy capacity by 2020. So these are the new India's energy policy. We just I want to give a hint so that you can have an idea where the oil and gas lies. I am emphasizing again and again that oil and gas will be the one of the prime source of energy for us, maybe 2020, maybe, I mean sorry, 2050 onward, maybe up to 2070, when our dependence on oil and gas will be reduced to 40%. Hello. So this is energy mix. Now, world energy mix is the world is moving away from the overwhelming dependence on fossil fuel. This we know of late that 2005, 2010, we have seen that people are using less and less oil and gas now, and they are going for more renewable energy source. So from 2005 level till 2015, share of oil has been fallen from 35 to 33%. So people are using that. Earlier it was 36%, it is now 33%. And but natural gas has increased to 23 to 24%. So renewable energy, including nuclear and large hydro gas, going up from 12.5 to 14%. So we are going away from the oil and gas. By 2040, India per capita energy consumption will be 503 kg oil equivalent per capita at 12 but to 2000 level to 1055 to 1088 kilogram oil equivalent per capita in 2012. The share of non-fossil fuel based capacity of electricity will be now our electricity is mainly produced from oil and gas or coal. That's the fossil fuel. By 2022 onward, by 2020 to 2020. By 2020 to 2030, our electricity use will be 57%, 60% of non-fossil fuel dependent. Maybe hydroelectricity, maybe nuclear, or maybe solar, or maybe wind. So, overview of energy of what's it? Why it is? I am just reducing this. Okay. Okay. So this is the whole slide. So up to just forecasting up to 2050. So we can see that gas and mainly that very coal part will be still there up to 2050, and nuclear will be very less, and our oil and gas still there in a, though of course there's a slight depletion of using oil and gas by 2050. So this you can see, this is projection up to 2050, all energy forecast. It's not going. So next is that where this energy will come from. We have seen the energy, main energy is 77% will be given by NOC only. And so small companies who will be there, NOC oil reserves, equity shares. So this is increasing resource nationalization, diminishing the assets. So non-OPEC struggling to increase production. Little spare of OPEC capacity. Depletion is real. So deep water will be will drive growth. So in E&P oil and gas, we have seen the deep water has got still value. So deep water exploration will be there for coming years. The technology answer to the energy transition, technology and techniques. So now this energy transition, since energy transition taking place, so technology is the answer for this transition, whether it is solar energy, hydro energy, nuclear energy, whatever, or ENP industry. So since I'll be talking mostly on oil and gas, so our technology developed in oil and gas I will be discussing on that issue today. So it depends that first let us understand what is technology and what is techniques. We are mixing up to technology and techniques. So technology is these are very closely related, but technology, if you have a technology but you do not have techniques, that technology may not work. Suppose you have, for example, you have got a very, costly car or latest development or latest model car, but if you do not drive, do not have the driving techniques, have seen how to negotiate with the bad road condition, the car will not respond to you. Similarly, in ENP is also similar thing. It's a bit. Suppose you are using a bit, latest technology bit, but if you abuse the bit, like say you hammer on the beat, you just running it very hard to the beat in the hard formation, so beat may fail. So these are the techniques, and but the beat has got a very good technology, develop new technology. It will definitely do its job provided you allow him to do the job. So this is the, to allow him to do the job is the technique, and doing the job is the technology by that particular tool or equipment. So that is the thing, that technique is a style or way of doing a thing or activity in a particular way, but technology refers to the complex process and principles of science used in gadgets and applications. So you can see different people apply different technique while using same technology. That is what I am talking about. That suppose you have a good mud motor. Mud motor is a technology, but if you are using, like if you are not allowed to work is honest limit, you are using with your technology bad handling, or bad handling is a technique. But this piece of equipment is bound to work on its technology. If you lower it, give the proper GPM and all, it has to rotate and it will do its job. So that is the technology. So different people apply different techniques while using the same technology. It depends on the skill level of the person. That's why skill is mainly depends on the technique. Technique is mainly depend on the skill. If you have good skill, you have better technique. You can better use it in a better way. Technology keeps the advance to make the appliance smarter and efficient. So difference between technology and technique. Application of science and engineering takes the step of technology. Technique is a manner or procedure that allows one to accomplish the same sort of task. The drilling process is a combination of successful use of both drilling techniques, depends on the skill level of the person and the drilling technology. So various drilling techniques termed as drilling philosophy are applied while carrying out drilling operations. So this is the point I want to make it here is what is the difference between a technology and a technique. So a technique is a manner or procedure that allows one to accomplish some sort of task. It is a manner, or is a procedure to work. But technology is a combination of use of both drilling techniques. Technology is a application of science and engineering. Okay. So drilling process is a combination of successful use of both drilling techniques, depends on the level of the person and the drilling technology. The various drilling techniques termed as drilling philosophy are applied while carrying out the drilling operations. This you can understand yourself. So what makes the difference of technology and technique? Drilling technology for petroleum industry. So drilling is a vast subset of whole ENP industry. Whenever you talk about drilling for oil and gas, it is a totally technology based subject. It is 100% technology based subject. So simply do not think that it is just rotating a bit at bottom and make a hole. Making a hole that is a usable hole. When we are talking about a usable hole, making a hole is not a problem. But it is a problem, big problem. But making a usable hole is under big problem. To make a hole up to 3,000 meter or 4,000 meter or 5,000 meter, that can be used for proper extracting of oil and gas safely is the main challenge to the drilling technology now. So now I am coming to the drilling technology part. So it is highly skill and knowledge based sector of the E&P industry and highly technology driven. Since the discovery of oil and gas, since people used to drill holes, people know that oil is there at the beneath of the earth crust or at suitable reservoirs. So we have to go there and we have to take out the oil. So people know it from very beginning. So initially they have dug oil, they have dug wells with using some primitive kind of tools. Then they go for the percussion drilling. Then ultimately they have used the rotary drilling type. And rotary drilling is one of the most efficient drilling technology developed maybe in 1800, early 1900 years. And development drilling technology is a century-year-old technology, and still development stays constantly, still developing. We know oil discovered in 1860 onwards. Since then, people are using drilling technology to drill well for oil and gas. Nowadays, it all-round development of technology in the drilling operation not only help in making the drilling operation faster and safer, but at the same time helps to monitor and download problems, geological information on real time, and hence increase efficiency. So use of technology doesn't mean that only to make the hole, but it is the efficiency. Then only you can survive in this competitive world. Because E&P industry, the more and we know that nowadays there is no easy oil. So all the easy oils has been taken already discovered and taken out. Now people are going for the more deeper and deeper horizon or more technological driven process, so that they can take out more oil at the same time. So that's why it is called a technology driven sector. Drilling is a highly technology driven sector. So development of drilling technology, this is a story. So you can go through. So what's it? One type of drilling technology is the important technology development takes place in the rig types. When people come to know that there is oil in offshore also, so offshore development has taken place differently. So initially drillings has been, that's why onshore rigs and offshore rigs. Onshore rigs are conventional, fast moving, and heli transportable also. And offshore rigs are, that bottom supported, floater, semi-submersible, drill ship. Nowadays, since all this semi-submersible, small shallow water has been exploited like anything around the world, there is not much oil in the shallow water now. So people are going for deeper and deeper water depth wells. So for deeper water depth wells, the deeper latest generation like 5th, 6th generation drills which have been made around the world, and semi-submersible have been constructed around the world. So this technology development is always going on to meet more challenges, to meet more challenges and more problem to go to the more problematic areas. So similarly, development of big technology. So 2000 up to 2000. This, of course, I'm sorry for this slide is limited up to 2000 only, but up to 2020 also, these developments is taking place around the oil, around the E&P industry. First, we are talking about this is a just chart. This is a table we want to show that how the defined technology is taking place or developed around the time. In 1900 years, there is only roller cone beams and casing cement. That technology was used. And in 1925, you see, BOPs has been developed, and multi-shot and whipstock has been developed, and bearing bits has been developed. Earlier, this and 1920, you see, first time electrical logging has been developed, and that too is sometime in 1925 to 1950, neutron log has been developed. So in 1950, you can see the top drive has been developed, PDC has been developed, insert beams, multilateral, and gamma ray has been developed. And in 1950 only semi-submersible rigs are coming out. in offshore wells. So before 1950, there is no offshore wells. Only maybe 1940 onwards, there offshore wells has been developed. And after that, you can see sometime between 1950 to 1975, MW in between, and maybe 1970, 68, MWD has been developed, subsea Xmas tree has been developed, Jacob rigs are coming because going to the more deeper wells. And 1975 to 2000, maybe 1980, 85, most of technology development has taken place during that time. So MWD also coming up during that time. And horizontal drilling is coming up, dual activity drill ships are coming up, LWD, RSS, steerable system, TCP, guns, expandables, these are coming up during that time only. So latest development is that casing while drilling with expandables and dual activity drill ships. That means you drill and you produce. Same time, the drill ship may work as a production setup also. This is dual activity drill ships. So emerging drilling technologies, so rotary steerable system, logging while drilling system, MW system, azimuth control tool, gyro surveying a specific objective, anti-collision requirement, quick stack pipe recovery tools, PBL tools, avoiding stack pipe, mud engineering technology like SOBN, casing drive systems. Though these are the drilling, so this is understanding how the technology has been developed to meet the deeper and more complex areas. Problematic areas like deep wells, deep water wells. So this is one of the drill ship, offshore drill ship. This is one of the also not drill ship. This is semi-submersible. This is a drill ship. So I am talking about the anchor drill ship now. This is technology how to work in deep offshore. So earlier the anchor drill ships were used to maybe go up to maybe 300, 400 meter water depth. So for a 400 meter water depth, you have to use anchor length of about 2 kilometers, which is very heavy. There may be another 8 to 9 anchors to keep the drill ship in place. So this is limited. So when your requirement is increases, they're going up to the 500 meter or beyond 1000 meter or 2000 meter, then this anchor drill ship will not work. So then these are you see how the anchor is handling. This is the anchor handling vessel. So they will lay the anchor, 8 anchors, to keep the position of the drill ship or the semi-submersible in place. And how the dynamic now, when you go for a deeper water well, so anchor will not work. So there you use the dynamic positioning system. How this dynamic positioning system works is it is a very big technology. So I am just naming the technology. What is a dynamic position drill ship? This is a ocean rig sailing having dynamic position and dynamic positioning system. These are dual rigs. These are dual rig drill ship. So one rig is making one hole, another is two ship work together 2 places. Drill ship concept. So this is very highly technological drill ship where everything is control or computer control, and human intervention is very less in some places. So the engine drill ship. So these are all everywhere. The technology is there. The engine also. This is a very high powered and high sophisticated engines. These are remotely controlled. Their maintenance, everything using their nowadays internet on tools, IoT. So that technology used to maintain this type of engines by remotely. So that's why it is reducing the downtime. So technology applications is everywhere now. And this is thruster. This is roll thruster. So it is a very power you can see 5,500 kilowatt. So it is power of this thruster is only 5.5 megawatt, you can see, right? So this load bearing capacity of the drill ships is just unimaginable capacity. You cannot just think of just like that. So this is the drill compensating systems. We know there are 6 independent motions in Also, while we work there, the drill ship is suffering from 6 kind of independent motion. It may roll, it may heave, it may go up and down, it may go front and back, it can roll also, it can rotate also. So to arrest all those kind of things, drill ship must have a very strong compensating system to heave, to attack, to avoid, to mitigate the heave and roll. So this is one kind of technology I am just showing here. You cannot think of, let's say, if you not work on it, you cannot think of how big this technology is and how but the all technologies are working on the basis of the science and engineering application. There is nothing but a hydraulic compensating system. So hydraulic oil is used only to, but the design you have to, the design is the main thing. It is this ground compensator active compensation. It is based on, it is mounted on the top of the rig. So cylinder stroke is 7.6 meter. Length of cylinder is 7.6 meters. Is too big. Maximum rig heave 4.6 meter. You see, 4.6 meter height heave or weight it can compensate. So those are the technology applications. But details we cannot go here. So it's very there's no point going into details. But if you want to work there, you have to know all those kind of things, all these things. So riser tensioner system. Another is that while you drill, is your bit is connected to your drill ship, but in between there is the ocean waves are there, ocean currents are there. So the riser tensioner system only used to, so that your bit is not impacting the formation due to up and down motion of the drill ship. So that compensation is done by the riser compensation system. So this is also technology development by seeing the working atmosphere of the in the sea. This is drill ship top drives. It's another kind of technology that has been used in all kind of rigs nowadays. In onshore rigs also these top drives are used, but these are very rugged tool based on these small engineering applications, small scientific laws and engineering applications. Suppose small, what should I say? Why should I am telling about small? Because this is mostly electrical motor driven equipment, or sometimes hydraulically driven equipment. So hydraulic power, we are just utilizing the hydraulic power, which is the basis of any engineering application. So only to utilize this thing in the technology, make a technology like you know that gamma ray, how we measure the gamma ray. So we know that gamma ray can be by Geiger counter only. So it is a Geiger counter technology, Geiger counter application. So that application is being engineered to measure the gamma ray or gamma content or gamma count in a formation. So this is the application. This is the scientific law, what should I say? This is the science that has discovered that gamma ray is there, but to measure the gamma, that Geiger counter is developed, and that Geiger counter is utilized in the gamma ray tool to measure the formation gamma. So these are the applications, how these engineering and sciences work together to develop the application. Yes. Hello. Yes. So drill ship drawwork. So these are the I'm talking about mainly mud system. I'm talking about mainly offshore technology. So capacity. These are the very big things actually. This is one of the very big. Is a BOP. So 1930 BOP and now 2020 offshore BOP is completely different. It's a very high technique thing, high technology based thing, and with highest application of engineering like metallurgy and all. So this is, so our technology develop. What is the main thing? Our technology develop as we see the problem. When there is a problem, our mind works how to avoid that problem. So therefore, that a technology has been developed. Something like that. So it is in offshore shallow hazards. How to avoid the offshore shallow hazards? This picture is showing that how you can encounter what are the problems in offshore shallow areas. So this is the total picture of how a deep water offshore is working. Where the BOP is situated, where the riser is situated, where the wellhead is situated, and where the rig is situated. You see, everything is shown here. So everywhere is this technology development. Everywhere, riser technology is a big technology. So this riser, this is about a 20-inch and very high metallurgy riser, and this has to take the pressure of the offshore from the reservoir pressure. So these are very like casing-like things. So this is technology that used there. And riser loading. How riser loading is how it is a current, how current and riser tensioner are working is shown here. So how the current, the drift off and current is being taken care in a drill ship or in a semi-submersible. It is shown here. For that, what kind of flex joints are there in the riser system is shown in the other side picture. So this is the riser, actual picture of a riser. This is the ROV. While it is going, is a remotely operated vehicle going down at the sea bottom and sits near the BOP and see the wellhead all the time. So this is how this is first sea bottom. How well is spudded. This bottom you can see there is a funnel like thing. So these things are first placed there. Then you run the bit and enter there. So while entering, because of your movement of this drill ship or this thing, you have to be very careful to enter that funnel. So this is the technique. So very high skilled person is used as a driller who can see that if you cannot, because the ship is moving up and down and sideway also the front or back, so you have to enter there. But if you are not able to enter in proper time, then you may break the bit and everything has to pull out. So this work where technology and technique works together. This is one kind shown here, how the current wave and currents are taken care of in a drill ship. Formation evaluation tools. One of the latest development is the formation evaluation tools like measurement while drilling, logging while drilling. These are the specific tools developed recently to see that was the formation actually bearing oil or gas or nothing. So this is one kind. Another kind of technology developed is the remotely operated monitoring, remote monitoring. Since this nowadays oil and gas operation is very risky and very costly, and so this operation needs constant monitoring by a very high skilled person sitting somewhere, maybe in base office. From there, he can direct all the operation, how is to be considered, how is to be conducted, and feedback, and foresee any problem beforehand, and the corrective measures to be taken accordingly. They will direct. This super skilled person sitting beyond the rig somewhere else, he can direct the operation by a remote operating center, remote control center, remote monitoring center, whatever you can say. So these are the systems nowadays used to remotely control the operation of a drill ship. This is also one of the latest technology. Now rig is drilling in maybe Bay of Bengal somewhere by a company, say BP. BP is having his central office in Houston. He can direct the operation in Bay of Bengal, sitting there and control the operation, and he can foresee any problem beforehand and offer mitigative measure accordingly on time or before time. This is one of it. Pharmaceutical logging, well monitoring remedial issues. Poor precise management with new age tools like seismic while drilling and unrelevant near-bit information for proper decision making. This is also one kind of technology, but not used very frequently. These are very costly technology. But and offshore regulations. But only that technology will not work alone. But you have to abide by the regulations also for a successful operation. So these are the regulations generally we are following in offshore. So we have to, while you go for offshore operation, you have to see these aspects also before going into the operation. So hello. Hello.
Yes,
hello?
sir. Yes, sir. 1 minute.
Any questions?
Someone mic is on. I'm trying to mute it. Yes, sir. Now it's muted.
Hello?
Yes, sir. You can please proceed, sir.
Okay, no question. Okay, so while working for any project, so we have to see, especially in offshore, we have to see the legal requirements. So well worked out and in place of oil spill response plan and where it help. Oil spill is one of the very hazardous operation. Generally happens in offshore. Offshore oil spill is very dangerous, not like onshore. Onshore is just you can mitigate and you can control also. It has got a limited effect of area, but in offshore it can spread to any place, and its litigation measures are very widespread. So you have to be careful about the oil spill measurement also. For oil spill also there are various techniques. So that is to be consulted and that is to be in place in case of any emergency. So that's why when you go for a project, you have to see in totality, especially in offshore areas, it is far more widespread regulatory requirements required. And apart from that oil spill, there are disaster management plan in place, major risks like loss of station keeping. Station keeping means we are drilling by keeping the rig in one place in offshore. But onshore rig, there is no problem because we do not lose the station keeping. But sometimes if there is a shallow hazard, like say we are drilling, but due to very loose formations, the formation collapse and the rigs sits down or rigs go down, sinks down. This may also happen in various onshore areas. So this is also called station keeping. So those kind of situation happens, and we have to be very careful to avoid those kind of situations. This is station keeping in offshore is a very big problem because due to ocean current or due to storm and all, sometimes or due to excessive heave, sometimes this anchor breakdown. If one anchor breakdowns, the station keeping is disturbed. So this is one of the situation where we have to be careful, and for that sufficient technological backup should be available on the day. And collision, sometimes collision is also of course remote thing, but some moving ships sometimes coming to the coming near to the drill ship and it collide with. So there is blowout and fire. We know the offshore blowout and fire is very dangerous. Recently happened in 2011 in GOM. And hurricane is one of the medevac and fatality accident, helicopter crash. So these are the catastrophic events in offshore. We have to be taken care while planning the well. Regulatory, so we are just another things that government rules are there. So we are not going for that billion. Oil spill regulatory requirements. So BP's estimation plan take 40 billion in November 2010 for the Macondo disaster. So oil spill is a huge liability for any company in offshore. So there are so many rules and regulations and technology are there, but once it is happened, no technology in a big in such a big scale, the technology may be overwhelmed, may not be able to control. So this is oil spill is one of the major disaster happening generally in offshore, not in general, but once it happened, it's very difficult to control. So there are laws and regulatory requirements in India. So regulatory requirements, then Director Hydrocarbon DJs and Director General Shipping, Director General Indian Coast Guard are the main regulator for offshore oil spilling. Regulator under Merchant Shipping Act 1958, Merchant Shipping Prevention Pollution Act by 1974, enforced by Port Authorities of Coast Guard. Central pollution again, and onshore we have central pollution boards and state boards are there. National contingency plan for combating oil spill, EEZ, Coastal Guard, and nodal agencies. So these are the regulatory requirements. Oil spill policy is there. So cleanup measures, Coastal PCB board, Coast Guard responsibility lies beyond port limits. DGIC has overall responsible appropriate response to oil spill. So when things go wrong, this may happen. So this is the disaster, this is the blowout. So people work. So this is one of the. I will finish it here. I like to take up some questions if you have. Again, I have one more slide where I would like to talk about the SOBM, which is one of the recent technological development in mud engineering for use in offshore wells, especially very problematic areas of subsurface problematic areas I'm talking about, where drilling is very difficult using the water-based mud. So one kind of mud has been developed that is called, earlier it has been developed as OBM, oil-based mud. Because of OBM has got so many negative points on environment, so another kind of mud has been developed that is called synthetic oil-based mud. So I will be presenting this on in my next presentation. I would like to continue. And in the meantime, if you have some question, I would like to take these questions and like to answer. Hello.
Can ask any queries.
Done. Ranjan. Hello. Hello.
Hello, good morning, sir. Sir, Prashant Bani here.
Prashant. Yeah.
Sir, thank you, sir. So, participants, I think participants have no query. So, if any query, I will share with you. So, participants, once again, you are requested. If you have any query, you may ask Ghana Gogoi sir, or you may write on our chat box also, so that we can share it with sir.
Right.
So I think there is no queries from participant side. So we may conclude our session. So on behalf of everyone present in this program, I want to thank and appreciate Ghanagogoi sir for his insightful and interesting presentation on the important topic that is your drilling technology. And I think participants also found the presentation very systematic, informative, and enlightening. And I believe everyone felt the same. Sir, Ghanagogoi sir, your lecture have covered all of the important aspects of your drilling technology. So it was our pleasure to listening to you, sir. And once again, from participants as well as from Dibrugarh University, sir, thank you, sir. Yes,
Person,
sir.
I have one small presentation regarding SOBM. If you would like to hear, I can present.
Okay. So there is another presentation also, no, sir?
Yeah, a small presentation on SOBM. So
can
let me
continue.
go back there. Okay.
Yeah. Yes.
Let me see how to go there.
Okay.
I'll go where? And how to go there? What is my presentation? Help me to go to my presentation.
Sir, another slide, different slide, or it is continuation of this present slide?
No, it's a different slide.
Okay, so you have to close this slide, then I have to go.
That is what I want to close it. Now, if I leave, I can come back.
No need of leaving, sir. On the right side corner, top corner, there is a close button is there. No? So you can close it, then again you.
It is not appearing. It is not appearing. Let me see if I can. Okay, now it is appearing. So it is actually hiding. So now I'll go for the synthetic oil-based mask.
Advantages of synthetic oil gas, no, sir?
Yes. This small presentation, but I like this smart system. Okay. So this is under presentation of recent technology. You can say this is one of the new technology used in drilling industry is that SOBM, synthetic oil-based mud. But OBM has been used since long in the industry. OBM has got some negative impact on environmental and very much negative impact. And the pollution control board generally doesn't allow to use this mud system in drilling operation. So that's why to meet that problem and to have the same advantage of OBM, one more mud has been developed that is called SOBM. And the advantage of SOBM, I'll be talking on this. I'm giving this importance on this system because now drilling is not very easy, and we are going deeper and deeper also in very difficult areas for drilling. In some areas where the formation is such that it is giving all the formation and instability problems, and thereby making drilling is a difficult task. So to avoid this all kind of things, like recently I have done one project in Oil India itself, that is Balimara. They have wells to drill in up to 4,400 meter, but they are having all the hole stability problem in the Giruzan and Tipam section. So, and they are using normal SOBM, normal water-based mud, and for which they are having all the problems of caving in or bit balling up, gumbo cells, and everything's are there. So to avoid that, at least they have not used till now, but they have used a different kind of SOBM, I mean water-based mud, that is called developed by Halliburton, I believe. So that is a high performance water-based mud, they say. So they're using few chemicals which acts just like a SOBM, but not SOBM, so that it will help them in avoiding the hole instability problem. There is a hole instability problem. So to avoid that, they have used this high performance water-based mud. But if we can use against that high performance mud SOBM, which may be less costlier than high performance water-based mud. So that's the opinion of the people now, that we can use the SOBM also. That's why I want to give some highlights about the advantage of this system. So first, why the need? Then what is LTMO? Low toxic mineral oil, and SOBM, synthetic oil-based mud. Constituents of SOBM package, toxicity LTMO and SOBM, advantage SOBM and disadvantage of SOBM. So why not WBM? First thing I told that WBM, water-based mud, has got so many disadvantages, especially where there is hole stability problem, or if you are not able to control properly the mud parameters, then it will give all the downhole problem that makes drilling operation is very difficult. You will have all kinds of problems like hole stability, pipe sticking, or making dog legs in degraded wells, pipe sticking problems, and so on and so forth. So that's why the WBM is not working properly in shale formations. As we know, all India is facing lots of problem in Kopili shales. They are having problems, same problem in the Kopili shales. So Kopili shale is highly, reactive to the water-based, and it is collapsing. Not efficient at high temperatures. Water-based mud is not efficient at high temperatures. Where HPHT wells are being drilled, this water-based mud cannot be used. So interference with flow and oil gas through porous rocks. Yeah, so it is sometimes we call it is a porosity impairability. So it blocks the pores, promotes disintegration and dispersion of clays. So water-based mud disintegrate the shale, and the clay becomes dispersed in water-based mud. Water-based mud dissolve the salts. So in salt section, water-based mud cannot be used for drilling. And not efficient lubricant as OBM. It has got all other problem of increasing the friction. So it will again increase the pipe sticking problem and all. So can promote corrosion. Water-based mud has got corrosion also. Corrosion nature also. High angle extended wells. They're difficult to use in high angle and extended reach wells. The water-based mud, it has got so many disadvantages, especially the pipe sticking problems and hole collapse problems. The shale hydration mechanism, you see, this is complete clay platelets, how it is showing in a true small this thing animation. I want to show the pore pressure, clay platelets, and how the hydration of stress takes place. Forces holding the place together, overburden and cementation. The forces pushing the place apart, pore pressure and hydrational stress. So the hydrational stress can be about 80,000 psi. You see, the hydrational stress. You know, hydration stress. What is hydration stress? That when water reacts with the formation, the formation gets hydrated, and it will exert extra pressure on the formation. So that is called hydration stress. So clay types, especially the snake type, elite, kaolinite, and chlorite are the most dangerous formation for water-based muds. So these are the OBM alternative to WBM. So these are the, you see, swelling, stuck pipe in cells, especially in cell, high torque and drag, change in stress, hole paper, NPT. So ultimately in cell, all these factors come together and increase your NPT. That's why OBM is used in place of WPM. OBM has been developed to overcome certain undesirable properties of WPM. OBM and SSD, or OBM with SSD is the best way. In OBM, what is OBM? OBM is SSD is the best way. Ideal alternative to combat the disadvantage of WPM. So in OBM, actually, diesel is used as a base oil. SSD is used as a base oil. We allow some other chemicals, the weighing materials, and etc. But OBM is adverse to environment, and dumping of cuttings is prohibited. That is the main thing. So it doesn't have the environmental clearance. Two alternatives were worked out. One is that low toxic mineral oil with aromatic content less than 1%, LTMO, and synthetic oil. LTMOs are derived from the same type of crude oil streams from which diesel oil, kerosene, gasoline, and lubricating oils are derived. So same oil, same oil stream, but having aromatic content is only 1%. Aromatics are completely removed or less. These oils are competent of paraffin. This oil composed of paraffinic or naphthenic components, mainly paraffinic and naphthenic. So same, oil-based LTMOs are used, mainly diesel oil, but with aromatic compound is 1%. That is the main point. Characteristic of LTMO is the low sterility and high initial boiling point, so high flash point, low viscosity, high ending point, low pour point. So all are the positive points. Low aromatic content, linear alpha oleins, and ether, etc. So constituent of LTMO, LTSOBM. Constituents, main constituent of LTMO or LTSOBM, low toxic synthetic oil-based mud, is the best oil. Primary emulsifier, secondary emulsifier, lime, brine, organophilic clay, or weighing material, SPST fluid losses. So these are the main constituents of any LTMO or LTSOBM. Advantage of LTMO and LTSOBM is cell stability. Main is cell stability. OBM is non-reactive to cell formation. Oil-based mud is non-reactive to, and higher ROP you can obtain. And high temperature tolerance, suitable for SPST work. Drilling salts in salt section, it can be used. It is not reactive to the salt section. And lubricity is very high. So minimize chances of stuck pipe. Reduce chances of stuck pipe. Low pore pressure formation. The mud weight as low as 7.5 ppc can be maintained. So where pore pressure is very low, it can be used very successfully because there is no low weight can up to 7.5 less than water can be maintained. Corrosion control. It has a very good corrosion control effect, all OBM. And reuse, they can be restored and reused. And Pecard fluid, LTSOBM or SOBM can be used as a Pecard fluid. But nowadays, what Pecard fluid we are using is just a simple salt solution like thing we are using in the well for production. But that may deteriorate over time. But LTSOBM or SOBM is not deteriorating. And disposal requirement of using LTSOBM for onshore drilling. OBM having aromatic compound content less than 1% can be under intimation to MOF and be used. So this is the thing that aromatic compound content is less than 1%, then it can be disposed with intimation to PSC as Pollution Control Board. Drill cuttings separated from OBM or washings should have oil less than 1%. So drill cuttings, bulk drill cuttings are after washing, if oil content is less than 1%, it can be disposed of. Or if it is more than higher than 1%, then it can be brought back to shore or to a designated place identified by MOEF or PSCB. But in Assam, there is no such designated place for receiving these drill cuttings of using SOBM, because SOBM or OBM is very sparsely used in Assam areas. Disposal required for using LTS for offshore. Bulk discharge of drilling fluid is prohibited. In offshore, bulk discharge drilling fluid. Bulk discharge you cannot do. Only drill cuttings can be removed. Only drill cuttings which has been separated in shell shakers can be removed at a controlled rate, not in bulk. Drill cuttings of any composition should not be discharged in sensitive areas notified by MOEF. That is the regulatory requirement. Drill cuttings water should be treated to conform to be limited by EPA. So biodegradability, you know that SOBM is highest biodegradable and low toxic. LTAMO is next to biodegradability issue, and diesel is very slow and complete biodegradable, incomplete biodegradable. So it is most dangerous not to be used at all. So despite SOBM, its cost is high. Kick detection is difficult in SOBM or LTMO. Not used in exploratory wells. Not used against pay zone, because if you use against pay zone, it will give a different result and or control, which may make you confused whether it is a oil bearing cell or it is a non-oil bearing cell. Rubber parts are highly deteriorated by the oil base. Selection criteria of OBM: when to select, how to select. Must be synthetically produced base oil. So OBM, when you are to use that synthetically produced, that base oil should be synthetically produced. Oil has poor environmental image, so lower toxicity usually associated with synthetics. So synthetic oil, that's why it is called synthetic oil base. Optimize environmental factors: high aerobic biodegradability, low toxicity, and chloride free. Low health and safety risks. So avoid low flash points. Best fluids, these are classified as inflammable. Low flash point use SOBMs are not used. So these are the advantage, disadvantage of SOBM, and I mainly go for SOBM because of this cell hydration problem. And Assam has got a very big cell hydration problem, and it is really very difficult to mitigate this problem using conventional WBM. Thank you. Any question, please? Any question, please?
Participants can unmute themselves, and if you have any queries regarding this session, you can ask the question to Mr. Ghanagogoi sir. You can also write your queries in this chat box.
Hello? Hello?
Hello? Yes, sir.
Yes.
I think there is no question from the participants.
Yeah. So I can leave?
Yes, sir. Thank you, sir, for your insightful and a very interesting presentation of.
Some questions appearing, but it is done.
Yes, sir.
Some questions appearing in chat box. I have seen.
Yes, we have one question from O. Obu Libda. The question is, what is the reason behind not using SOBM in pay zones?
I have already explained. Use in the pay zones, it will be very confusing for you to really characterize the formation, reservoir formation, because it's the oil. Sometimes you see Sometimes when pipe got stuck in the pay zone, if we use oil as a spotting fluid, it will give you a different kind of result in the log also, because log penetration, because definitely oil go into the formation, reservoir formation. Your surface oil, that's the base oil, will go into the reservoir formation and show the log characteristics like a oil bearing cell. So it will make you difficult for really analyzing the surface formation characteristics of the reservoir. We have one problem. I can give you an example. In one of my wells at the pay zone, we got a stuck pipe, and we use diesel oil to as a spotting oil to make the pipe free. And ultimately, we make the pipe free, and well was logged, and core was taken, because core conventional core was taken, not conventional sidewall core was taken, and all cores found to be very highly, your resistive, because of that diesel oil was used, and that was really misinterpreted thing, because it's not be that much high. So we know that we have used oil, that's why it is coming like that. So that is the it may misguide you if you use oil against the reservoir formation. Okay, thank you.
Thank you, sir.
Thank you. Thank you, ma'am. So,
If you have any queries, participants can write in the chat box.
yeah. I have also some interesting slides here. I like to share with you what is the recent technology in RSS. Would like to hear?
Yes, sir.
So this is, I had mentioned this thing in my previous first presentation regarding the this technology that has recently developed. So one such kind of technology was RSS, which I have mentioned earlier, and I like to give some more light on this principle, on this technology. So I like to go through this. Let me see. Benefits of RSS. I like to go. So this is the RSS. This is not, of course, Rastriya Sevak Song. It is the rotary steerable system. Okay. So I like to give you a history how this technology has developed. So first RSS system, vertical drilling system, was conventional continental deep drilling (KTB) project was in South Germany in late 80s. So RSS was developed in late 80s. System contains a linear bit inclination sensor, a downhole processor, steering reed on a stabilizer just above bit. System principle closed loop process. So these are the development of technology, how it has developed. Some questions has appeared, I have seen. Ma'am?
Yes, sir. One more question has been given by Obu Lipta. Sir, if you have an idea to share about the recent trends in POB technology after Macondo well incident. Sorry, BOP.
Was the later part of the question?
To share about the recent trends in blowout preventer technology after the Macondo well incident.
Okay, so this is also here, I believe. Let me go through. Yeah, after Macondo BOP, BOP is saying, so similar BOPs we are still using with foolproof system with fail-safe system. Macondo BOP was a good BOP, no doubt, but the foolproof system was not working. Fail-safe system were not working. When it gets delayed, so everything was failed. And one is failed, that the whole the blowout has occurred and it become unmanageable for BP to control that blowout with a BOP. Since BOP has failed, they cannot rig up another BOP on the top of the wellhead. So ultimately, one technology has developed. I'll start my my slides. One technology has been developed in. I'll come back. Here, maybe yes. Here. So you see, this is the latest technology breakthrough, the well cap. The well cap technology has come into place now. Once the blowout is occurred, there is no means to establish rig up a BOP there. Then well cap technology, a breakthrough well cap technology. This is called breakthrough well cap technology has been developed. That's the off-sprat capping device. This is called off-sprat capping device. So off-sprat capping device, after Macondo industry has developed a device to cap a flowing well, which is a technology breakthrough. It's a technology breakthrough. It is a off-sprat, they call it a capping device. The cap is known as OSPRA, Oil Spill Prevention and Response Advisory Group, OSPRA. Well cap, a 15K well cap developed by Cameroon and successfully tested and stimulated. There are only 3 or 4 this type of well cap around the world now. One is Singapore, maybe one is North Sea UK, maybe one is South Africa, and maybe one is in America only. So there is 4 or 5 this type of well cap, very heavy well cap is available in the world now. This is the new technology developed after the Macondo disaster. So I think I have sufficiently answered to your question. Hello? Hello?
Yes, sir. Thank you, sir. Obulipta has thank you in the chat box.
Okay, sir. Thank you. So I'll come back to the my original presentation about RSS and all, how the things are developing. But I'm not talking about the RTOC. RTOC is one kind of technology recently developed. Functional RTOC, and also I have PDC development is also there. This is one of the fragile PDC. This is, you see, this works like a auger like bit, which is a very old technology. Auger is a very old technology. Wood auger, we have seen wood auger. So it is auger type BOP, I mean bit. So this is also recent technology in PDC bit. So this is National Oil Well barcodes, NOV bits are there, and Halliburton drill bits are there. Geotech bits. These are very highly, I mean, high technology bits, high end bits. We call it high end bits. So I'll start from this, from here. These are the high end bits that is developed by various companies like Halliburton, Baker, Schlumberger, and all. So hybrid chimera, this one of the hybrid bit chimera developed by Baker is a chimera bit. It's combination of both roller and fisting. They call it a chimera bit. So the success rate in this type of bit, we have success history in Mizoram, where we have drilled very hard sandstone formation from very top, about 3,500 meters with this kind of bits. So after recent development, Halliburton bits are also Geotech PDC bit. These are also very good bits, recent development, and also national bits are also good. And this is PDC logic introduction by Fragdrill. This is also, you see, this is auger type bit in formation where the formation will be cut and lift, cut and leave through the slots of the bit, and after that it will lift out. So this is a very recent development bit. So PDC bit by RSS application. For RSS, the Ultra Drilling Technologies has developed a PDC bit optimized use for assemblies equipped with rotary stable system. Rotary stable system needs actually very high RPM first thing. So to have to make the bit cool, we need very high GPM. So that means a high GPM means it gives high ROP, high penetration rate, and gives more generation of cuttings. So our aim is to our job is to leave the cuttings as soon as it is generated at the bottom at the base of the bit, so that no grinding takes place. So to have that facilities, so this Ultra Drilling Technologies bit, they have developed. You can see in the profile of the bit that the water course, I mean that flow circulation parts, which are designed in such a manner that as soon as it is generated at the bottom of the bit, it is lifted up immediately, so that there is no grinding takes place. This is one of the ways. So another is RTOC. As I told in earlier slides, the RTOC is one kind of technology developed to have multi-phases monitoring. So in earlier days, well was drilled in a remote place by the driller, and very less human intervention was there, very less skilled manpower feedback was there. Nowadays, it can be drilled anywhere in the world, and best of the best people can monitor the operation and foresee the operation and suggest mitigate operation and mitigating the problems. So this is called remotely controlled operating center. This is how we are using the remotely controlled operating center. So benefit of the remotely controlled operating center is that you can foresee, you can hear the well remotely sitting in a distant place, that what well is going to tell, what well is telling to you, and if there is any problem, you can foresee, you can suggest the mitigating measures and take action according to avoid that problem. So these are the basic advantages of RTOC. For example, say nowadays mud logging unit is there. Every drilling unit has a mud logging unit. So if mud logging units, you can monitor only 2 or 3 parameters, like while drilling, if there is any gas or connection gas, it will show. If there is any torque increases, it can show. If there is any cuttings is more or cuttings is less in the vibrating scheme, it will tell. So a skilled person sitting in a remote area, sitting in a, I mean in his base office, he can tell that these are the things coming up now. Your torque is increasing, your cuttings are not there in this screen, so you may be cutting loaded. You circulate or you circulate, or you give a high speed to lift up the cuttings before drilling ahead. Something that way he can see or he can hear the well. So these are the expert people's work. So to monitor from remotely by the expert people, the RTOC is helping. So this is the RTOC. So benefit of RTOC. So MPD, now managed pressure drilling, also one of the major technology. Along with managed pressure drilling is casing while drilling. In most problematic areas where drilling becomes very complicated or very troublesome, you are not able to make progress or making hole, and you have all sorts of problems like hole caving in, stuck pipe, mostly stuck pipe. So to avoid that, those kind of formation, to drill those kind of formations in one go, there are some technology has been developed. This is called managed pressure drilling technology, and there is also called casing while drilling technology. In casing while drilling technology, you drill with the bit, with a PDC bit, which is drillable again. So PDC bit run with the casing and drill, and set the casing dry itself, and after that in next thing it is drill out. So these are the new technologies coming up now. People are using, especially in those kind of formations where you have total loss situation. Suppose you have a total loss situation in upper zone before reaching the formation, reaching the reservoir. You have a very problematic zone of that total loss zone. You are not able to manage. Hello, I am going out of my this thing battery. Let me see. Okay, please hold on. So this is how the back pressure is working in a managed pressure drilling. Our CD rotary control device. These are the equipments. These are the equipments, but this is also technology. This technology helps to carry out the managed pressure drilling, back pressure drilling, riser booster pump. These are the MPD simulator also there. So casing while drilling next. I'll go for the next section now.
So we have a question from Mr. O. Abulibda.
Yeah.
He's asking that in deep drilling, there is a new trend to use plasma bead technology rather than the ordinary PDC that may not favor conditions of high temperature in ultra deep wells. It is currently used in geothermal drilling. Sir, from your long experience in oil and gas, do you have any idea if the plasma technology has ever been used in petroleum drilling?
So far I know. No, I heard the technology, but I have not gone through that technology also. To be frank, I don't know. This much I can say by sure that in India this technology is not used in oil and gas. Maybe in USA or that side where geothermal drilling is going on, where it may be used. I do not know that. I don't have any information about that. Sorry. It's okay?
Okay, sir.
So I would like to give a few slides on rotary steerable. So this is the history of rotary steerable system, how it has developed. So in 1990, as Baker Hughes Intake developed the RCLS, rotary closed loop system. So this system we have used in Oil India earlier, not now. And the benefits, you see the benefits of RSS is mainly the giving better control of the azimuth and everything is better. When RSS is used, you have MWD, and so for that high displacement angle or deviated wells, this RSS can be used very well. In vertical also it can be used. In vertical wells, of course, nobody do nowadays except very deep or exploratory wells. So less risks of being differentially stuck, motor BSC stays on non-rotated while sliding. In mud motor and RSS, difficult mud motors we have to keep the mud motor and above PSA in stationary position while sliding in. So there is a chance of sticking during that time. But in RSS, it is all the time rotating, so there is less chance of differential sticking. RSS BSC rotates all the time. Some RSS system has no rotating sleeves. Some RSS system has all the external parts rotates. So the better rate of penetration, PDM versus RSS. You can see these are the reds are the PDM and blues are the RSS. So ROP, as you can see, this ROP is always greater than the PDM. So better hole cleaning It is continuously rotating. So these slides I will be definitely sharing with you. Typical surface rotary speed man motor is 50 to 60 rpm, up to 80 rpm, but the RSS BSA can be 100 to 100 rpm you can use. So benefit are also better borehole quality, smooth. There is no sliding, there is no dog leg. It's continuously rotating. But in case of PDM, there is sliding, so your make hole increase, decrease, increase. But in RSS, you can make a smooth deviated hole. There is not much variation in angles and inclinations and azimuth. Now, what are pipe sticking with is sliding mode. So some pipe buckling issues in sliding mode. When you slide, you give more weight on the PDM, so the pipe got buckled. But in RSS, since it is rotating all the time, the pipes are not buckled. So this vertical drilling in highly deep formation in China Sea. So similar kind of wells we have drilled in Mizoram also using RSS camera bit. So this is called vertical drilling. So this is due to that high deep in that area, high deep, while you use the rotary system, due to high deep, the angle, the bit automatically slides off and making really deviated well. So to avoid that, we have used the vertical drilling. So that whenever it goes 5 degree more than 5 degree, then vertical, it comes back to other side of the pad works and is come back to the normal position. That is the basic principle of working of a RSS in a vertical mode. So RSS taking principle are 3 principles are there: push the beat, point the beat, and hybrid deflection of drill bits of center. So these 3 principles are used in RSS. So these are the RSS development in the market now. Becker uses AutoTech family. Becker uses AutoTech families are there. So Halliburton Geopilot family, Schlumberger Power Drive system. So these are different names. Weatherford Revolution RSS family. So these companies are making their own name. Other RSS system and APS technology is there. So they are making push type beat. The gyro data well guide is a point to the beat, and NOV they are making push the beat. There VC drilling they are point to the beat. So these are the companies they are making the RSS system with their parameters showing. So APS Sure Steer is one of the RSS system developed by APS. So there are recent technologies for studies. So very shallow surface to do in-seam SIS design. These are the design parameters of design and utilization parameters of RSS. So this is RSS, utilize RSS power drive. This is one of the case histories. Rate of penetration I have shown already. So Indian operator drill 5,000 meter with 2 to 3 degree inclination in highly faulted zone with vertical system of RSS. I have just told you. So this has appeared in here. So challenges: maintain vertically high deep and faulted formation for coring and logging program. Observe high build tendency from offset wells. Solution: automated vertical drilling system, power B, 100% verticality seeking system. No input required from surface. Maximum weight on beat applied. Not required for control weight on beat. So what next for RSS? More robust systems to access more challenges target, more cost effective, higher. So wired drill pipe are more efficient in control downward push, including RSS and troubleshooting. Nowadays, wired drill pipe helps to come, so which you can get the information electrically at the surface. Now we are depending on MWD, LWD, some pulse system. So this is more efficient the wired drill pipe, but these are very costly. These are the big technology I have shown already. So with this, I think I can conclude my presentation regarding RSS, bit technology, RTO, PDM, but what is it? Casing oil drilling, managed pressure drilling, and RTOs. I think I'm successful in doing that. Okay. Hello?
Thank you, sir. Thank
Any
you for the
question
nice.
now? I can take one or two questions.
Yeah. Any more queries? So one more is there. Is RSS HBA easy to handle phishing operations compared to conventional systems?
When this pipe got stuck, RSS got stuck. Generally, RSS generally do not get stuck in normal condition. But if you have a problem, suppose there is a sudden loss and whole collapse and everything is buried, then it is difficult. So phishing operation in RSS, not that RSS may get phished, may get stuck, and if when there are so many situations in occurring a phish, suppose a Trojan failure. This is unexcusable. Trojan failure, unexcusable happening that may got phished. Then pipe sticking. If there is pipe sticking is there, so RSS doesn't get pipe got stuck in RSS because it is rotating all the time. But as I said earlier, if you face a total loss problem, suddenly whole mud got lost and whole is collapsed and whole BSA is buried, then of course you don't have any way to work, right? So in that case, it whole thing will be very difficult to fish out. So your question was that is it difficult to fish out the RSS? Is it that? So I think that in normal condition, not difficult to fish out the RSS. But in case I have described, when there is a total loss and whole is collapsed and whole BSA is buried, then it is difficult. Right? Thank you.
Any other query? I think there is none. So on behalf of everyone present in this program, I want to thank and appreciate Sri Gogoi sir for his insightful and interesting presentation on the important topic of drilling technology. I found the presentation very systematic, informative, and enlightening, and I believe everyone liked it. So your lecture covered all the important aspects of drilling technology. It was a pleasure listening to you, sir. So once again, from DibrUgarh University, I thank you, sir, for accepting our invitation and speaking to us today. Thank you so much, sir.
Thank you, Rohan. Thank you very much. Thank you, everybody. Bye.
Thank you, sir. So now we will have the break. Please join me again at 12:30. So next session will be on biomass conversion by Parikshit Gogoi of Nagaon College. So please join me again at 12:30.
This conference will now be recorded.
Hello, Parikshit sir. We can see your slide. Parikshit sir, am I audible?
Am I audible now?
Yeah, yeah. We can see your screen.
Yeah. Okay.
So welcome once again. So this is the second session of day 5. It's my pleasure to introduce our resource person for this session, Dr. Parikshit Gogoi of Nagaon College Autonomous, who is going to talk to us on biomass conversion to fuels and chemicals. Dr. Parikshit Gogoi is currently serving as Assistant Professor in the Department of Chemistry, Nagaon College Autonomous, Nagaon. He obtained his master degree in chemistry from Cotton College, Guwahati, under Guwahati University in 2002, and MTech in Petroleum Refining and Petrochemicals from Dibrugarh University in 2003. He obtained his PhD in Chemical Engineering from CSIR NIST in 2010 under Dr. P.Z. Rao, former Director, NIST, Jorhat. During his PhD, he worked on enzymatic synthesis of tea polyphenols and study its kinetics and mechanism. His current research interests are biomass conversion, synthesis of metal oxide nanocomposites, and absorptive separation of natural products. He was awarded the Summer Research Fellowship for Teachers in 2014 by the Indian National Academy of Science, Bangalore, and worked in IICT, Hyderabad, India, to develop some ceria, iron, and molybdenum-based metal oxides for synthetic applications. UGC India awarded him the Raman Research Fellowship for postdoc research in Indian scholars in the US for 1 year, from 2016 to 17, and worked at Chemical and Biomolecular Engineering and Renewable Bioproducts Institute, Georgia Institute of Technology, Atlanta, USA, with Professor Yulin Dang on converting biomass to biofuel and valuable chemicals. Till now, Dr. Gogoi has published 20 research journals in journals of national and international repute and has been cited more than 500 times. He published 3 books and 3 chapters in edited books, along with 6 international conference proceedings. He supervised more than 30 MSc, BSc students for research work and guiding 4 research scholars for PhD. In addition, he has demonstrated a strong professional association and served the research community at large, as indicated by the number of his conference presentations. So please join me in welcoming Dr. Parikshit Gogoi, sir. So over to you, sir.
Thank you, Dr. Ranjan Fukan, for a very nice introduction of me. And in fact, I am very privileged to have a privilege to be a resource person in a department where I earned my MTech degree from Dibrugarh University. So I am very happy today that I am sharing some of my knowledge that I gathered in last 5 to 6 years. Actually, I started working on this biomass field from last 5 to 6 years back. I have started my work, and still I am in the learning stage of biomass conversion and electricity production from biomass. So in this, actually, though the Department of Petroleum Technology, they invited me for this faculty development program, still I'm a beginner, so it is like very difficult to give a talk like a resource person as earlier speakers have given. So still I will try my level best what I have learned in my postdoc experience in United States, and it is a couple of years that I'm working in a lab for the biomass conversion to biofuel production. Okay, so I guess all the participants are from the diverse field, so I just try to give a very general introduction of this research area, how people are working and what is the basic requirements for having this kind of activities, research activities or academic activities in biomass conversion fields. And so am I audible now? It is clear and visible. So I guess I need to actually for some time I need to switch off my video, since this from morning actually my Wi-Fi is a little bit disturbance. So I'll just put it off my camera so that it will be very clearly audible. Is it okay?
Yeah, no.
Okay. So actually that when we are thinking of about to have some energy from biomass, before that actually we need to think of little bit differently. That one of the most important challenge in 21st century is that the reduction of global warming, while this satisfying the growing energy demand. So it is the basic necessity of our society, that how we are going and how we are developing. So nowadays, if you looked at the energy scenario in India as well as in like different countries like United States or UK or other countries, most of the fossil means energy are from fossil resources, but due to the environmental concern, together with the depletion of crude oil resources, consequent increasing price and the consequent increasing price of raw materials are becoming important driving force to encouraging people to search for new feedstock as alternative of crude oil to meet the increasing energy demand. So many different possibilities have been have come out. However, such substitutions involves important requirements like a renewable nature of the raw material to ensure the sustainable supply of the material. Nevertheless, a very high availability seems to be another one of the most important requirement, bearing in mind that the high quality feedstock needed. We really need a high quality feedstock to ensure full coverage of current demand of automotive fuels. So in this case, actually, biomass is one of the few resources showing the high potential to meet the challenges of sustainable and green energy. So for a better future, actually, several governments have implemented mandatory legislation in order to increase the gross domestic energy from renewable resources, especially from the biomass. If you looked at the United States Department of Energy, they set ambitious goals to derive 20% of the global, 20% of the transportation fuel from biomass by 2030. As we know that in United States, they're blending bioethanol in their motor speed. So also together with United States, the European Union also has set their mandatory target of 20% for renewable energy share of energy consumption by 2020, as well as the mandatory minimum target of 10% of renewable energy sources in transport. Okay. If you look at India actually planning to have 50% share of energy from renewable energy by 2030. So these are the goals of some of the countries, especially countries like India. India also looking for some technologies from where you will have lots more energy substitutes, and this may be biomass may be one of the important substitutes for this replacement of fossil fuel products. So if you look at the world energy consumption by in actually 2018, there is a data that in 1980 it is around 282 quadrillion of BTU in 80. Actually, that is the total energy requirement, and it is increases by 48% in 2010, and it will increase up to 48% by 2040. So what are the some of the disadvantages of using these fossil fuels? That includes the greenhouse gases, that is emission of greenhouse gases. Maybe that most of the speakers from the other previous sessions, they have maybe discussed this. I'm not going for details of that, but if you look at the carbon dioxide emission, and it will if you look at the the amount of carbon dioxide means emitted, it will increase by carbon dioxide emission. Actually, that the estimate is that by 2050 that the temperature rise up to 1.5 to 4.5 degrees centigrade. This is estimation. So nowadays, so people are looking for that substitute energy sources. And if you looked at some of the advantage of the using that, what we can say, that biomass as a fuel precursor, that use of biomass, actually, as you know, that these carbon dioxide will release due to biomass use has previously been used to grow plants through photosynthesis. Unlike fossil fuels, biomass energy is regarded as carbon neutral. So we can say that biomass is a carbon neutral source of energy, and by use of this carbon means carbon neutral means sources, the use of biomass energy may provide like several benefits, like decrease greenhouse gas emissions, means that means that cleaner environment, and then decrease foreign sources dependence as a result of replacing imported fossil fuels with biomass, and development of economic opportunities to rural areas. And another one is that a decrease was disposal issues. So these are some of the
Sorry to interrupt.
Okay.
Pariksit, sir.
Yes.
Sorry to interrupt. Your slide.
Okay.
Your slide is not moving.
Yeah.
It's on the first slide.
It's okay. Like introductory part, actually, I'm a little bit slow in making slides, so I am just means giving the introduction part by my own, so that I didn't make actually slides. So when I means going to means change the slide, it will little bit technical. So before that, I'm like discussing some about the initial points by from my own. Actually, I didn't prepare that slides. Okay, thank you.
You can you can make it slides.
Okay, fine. Actually, that United States is one of the leading countries for biomass conversion. Biomass conversion. Now it is moving. Now it is changing.
Yeah, it's changing. If you can make it slides. So.
Okay. Yeah, I'll make it slides. Fine. Okay.
Yeah, it's perfect.
So actually, that one laboratory in United States, National Renewable Energy Laboratory, along with the European Union, they set a term of biorefinery. So what is biorefinery? If you looked at the biorefinery concept, that it is like very similar to petroleum refinery, and according to the NRL, that biorefinery is a facility that integrates biomass conversion processes and equipment to produce fuels, powers, and chemicals from biomass. So the biorefinery concept has come out, and people are working on that. So the biorefinery concept is analogous to our today's petroleum refineries, which can produce multiple fuels and products from petroleum. That industrial biorefineries actually have been identified as a most promising route of creating the new domestic biogas industry. So what is the objective of these refineries are that it produces the multiple products. Say a biorefinery can take the advantage of difference in biomass components and the intermediates and minimize the value of derived from the biomass feedstock. The main objective of the biorefinery is to produce high value, low volume chemicals, chemical products, and low value, high volume biofuels using different unit operations while generating electricity and possesses heat of its own, and perhaps enough for sale. Okay, so that is the main part. Actually, high value products actually enhances the profitability, and this high value fuel helps meet national energy needs also. And here actually today the highlights are that how the biomass can be converted to the biofuel production. biofuel production means biofuel means especially we are talking about the bioethanol and biomethanol production, and then that lignin isolation strategies. That is one of the main major issues of the current biorefinery concept, that how lignin can be isolated and strategically. And the third one, third highlight, that is I'm going to discuss about the bio oil to hydrocarbon fuels, and then the last but not the least, the very important, the biomass fuel cells. So these are the highlights I put for this session. So before going for these highlights, actually, I want to means what is the background and motivation means for working on biomass. So if you looked at the any biomass, that we can say in general, if you search in Google, any search engine, that then you will have that biomass means lignocellulosic biomass. Why it is called lignocellulosic biomass? That it contains, suppose wood or grass or anything that means grassy materials or any rice straw everywhere. And if you consider this is a lignocellulosic material, then it consists of cellulose, lignin, and hemicellulose. So these are the three main components of uh, any biomass in lignocellulosic components. So as we know that a traditional pulp and paper making industry, what they are doing, that they are making hollow cellulose. Hollow cellulose means hollow cellulose is termed is used for the combination of cellulose and hemicellulose, and it converts to pulp and papers. So whatever paper we are getting, that is the main source is cellulose, that is from coming from bamboo or any other woody materials. So lignin, that is a aromatic chemicals that is responsible for the means in color, brown color in any woody material is the chemical component is lignin, and it is very like highly cross-linked kind of aromatic chemicals, and carbon number is very high. So in every till now, in actual factories in paper pulp and paper making industries, lignin is underutilized. Means in industry it is like they are using for burning to produce heat. Actually, what is hemicellulose? Actually, what is the role of these cellulose, lignin, and hemicellulose in plant materials? If you looked at that, hemicellulose acts as a blocking seal, limiting enzyme access to the cellulose and hemicellulose complex. And lignin forms physical barriers, resistance to means microbial attack and hindering polysaccharides hydrolysis. So one article published in Science in 2014, they actually very nicely, clearly, they have demonstrated that how biomass and how the biorefinery concept can be converted to useful chemicals and fuels. So if you looked at that, they actually pointed out some very good points, that biomass conversion technology, that it won't affect the food, feed, and fiber production. So that is the main point, that how that it will not affect the food chain, and it provide advanced chemicals, materials, and sustainable fuels. So till now, the biomethanol from cellulose has been commercialized and used as a liquid transportation fuel in some countries, and upgrading is still under fundamental research, and the potentiality of lignin is that from the lignin you can produce carbon fibers, composite materials, advanced chemicals, and industrial additives and fuels. All these are possible from actually that lignin part of the lignocellulosic material. But till now the research is in very primitive stage. Means those who are working on that, if somebody is working on lignin, and it is very it is like high time to demonstrate their research ability to, if somebody is working on lignin, and as too many works are means possible in this area. So what are the common types of biofuels? If you looked at the common types of biofuels are that bioethanol, biomethanol, biogas, and biodiesel. All These terms are very common in everywhere. The means these very common terms are here: biomethanol, bioethanol, biodiesel, and biogas. These are all actually common types of biofuels. And biofuels you can have from different lignocellulosic or agricultural food residues. Means by using agricultural residues, you can have biofuel by using some kind of technologies, and some technologies actually available in the leading institutions of this biofuel production are like MIT. In MIT, Massachusetts Institute of Technology, Chemical and Biomolecular Engineering, one professor Yuri Raman, he is working on this biofuel production. Say another person, the very renowned person of the top energy leaders like Arthur Roguskas, he is working in University of Tennessee, Knoxville. He is also working on that. And from Georgia Institute of Technology, they are also working on very nicely on how this biofuel can be, a waste material can be converted to wealth. So these are some of the institutions, especially in European countries. If you look at that, Aalto University is also one of the pioneer of working on biofuels. So now, if you look at what is biogas, actually, biogas is a mixture of carbon dioxide, methane, sulfur components, and nitrogen and hydrogen. These are the main components of biogas. And biodiesel, a clear liquid, the monoalkyl esters of vegetable oil or animal fats. These are some of the chemical compositions. Since actually that for this lecture program, I think that most of the persons are not from the chemistry, so I didn't put the actual structural pattern. I'll skip a little bit of chemistry, and I will try to make it a little bit general so that the other participants, all the participants may have some basic ideas from this presentation. So measure that if you looked at the percentage wise, wood is like different kinds of woods are there, hardwood and softwood. And if you looked at the percentage of cellulose, it will have 43 to 47% in popular hardwood, and hemicellulose is 36 to 39%. These both hemicellulose and cellulose are called as a called we can say that hollow cellulose, and lignin is 17 to 23%. This 17 to 23%, actually this is in the present days it is used for burning and produce heat. And that's for softwood like pine, it will have 46% of cellulose, hemicellulose is 23%, and lignin is 20%. Similarly, then agricultural was like corn cobs, wheat straw, it will have different percentage of cellulose, hemicellulose, and lignin. Similarly, for grass also, Swiss grass or miscanthus, you will have different compositions of these three components, main components of the lignocellulosic biomass. So based on the technology and the biomass type, we can divide our biofuels to primary and secondary biofuels. So primary biofuels, as we from the firewoods, wood pellets, chips, forest and agricultural residues, and gases, all these are considered to in the primary category. And secondary biofuels is the first generation, second generation, and third generation and fourth generation biofuels. These are called secondary biofuels, and it can be produced from different lignocellulosic materials. The first generation biofuel, as you can see in the slide, the bioethanol or biobutanol from fermentation of starch or sugars containing food crops. Like if you can take sugar and if you extract the sugar juice and directly you can convert it to the ethanol. In earlier days in Brazil, they are producing ethanol from sugarcane. But nowadays the second generation and third generation biofuels are very important. Second generation means biofuel, that is bioethanol and biobutanol, or synthesized biofuels made from non-food lignocellulosic biomass, that is not non-food. And third generation biofuel or bioethanol from microalgae or seaweeds or microorganisms. And fourth generation biofuel produced using genetically modified microbes or microorganisms. Among these, bioalcohols, bioethanol and biomethanol are important from economic and technical potential perspectives and for combustion engines. Actually, we looked at the bioethanol production, laboratory ethanol and laboratory methanol production. In this is actually biomethanol production from lignocellulosic biomass. I am showing one schematic that how biomethanol can be produced from carbohydrate biomass by gasification. In actual practice, what they are doing, just they are collecting the waste materials like rice straw. They are collecting, and what they are doing, they are washing and they are drying it, and they just do it the gasification above calcium. They are doing the gasification in presence of oxygen, that is the process of calcination above 100,000 degrees centigrade, and it will convert all the biomass molecules, biomass material will convert it to the mixture of gases like hydrogen, carbon monoxide, carbon dioxide, and hydrogen gas. And after that, they producing the gases from the gasification. That catalytic synthesis means shift reaction can be possible for the methanol production, methanol synthesis reaction. Here actually cuprous is used as a catalyst for this process. So this is actually, this technology has been already developed, and by this way methanol is produced in different countries. Technology is already developed. Am I audible now? Voice is okay?
Yes, sir, you are audible.
Okay. So if you looked at the total global production of bioethanol by major producing countries in the world, here you can see that the 57% of the total bioethanol production is in United States of America, and second 27% that producing country is Brazil, and 6% is European countries, and this one 3%, about 3% from China, and 2% from India, and 5% from the rest of the countries of the world. So in United States, now they are producing 15,000 million gallons per year, and in Brazil they are producing 7,000 million gallons per year. So this is the current bioethanol production scenario of the globe. So it is like from Indian continent, we are producing only 6%. And if we increase this, suppose if we blend our petrol with 15% of this bioethanol, that we are reducing our carbon dioxide emission by 15%. That is the advantage of the blending of ethanol in petrol. So in a common pretreatment process, actually for bioethanol production, the first step, that for second generation biofuel production, the main concept is the main step is pretreatment. So what is the pretreatment? After pretreatment, you will have the pretreatment. Actually, what it is doing, this is a schematic illustration of pretreatment process. In pretreatment process, you can do lots of pretreatment processes are available. And this, by doing the pretreatment, you are actually carbohydrate is a little bit free after pretreatment. Means you are removing the lignin and hemicellulose part from your what I can say that woody material or lignocellulosic material. So I'll just skip this slide. So some common pretreatment methods are available. Like biomass, you need to do pretreatment for bioethanol production. So the three different methods are available, like physical, biological, and chemical methods are available for pretreatment. Physical methods includes irradiation, that's sonation, ionization, cold plasma, microwaves, and shock waves. Physical methods include milling, like ball milling, vibratory mill, disc refining, hammer mill. Then biological method means enzymatic or biodegradation. And then chemical methods includes basic treatment like alkaline, overlime and ammonia, acid treatment like by using dilute acid, organic acids, concentrated acids, Lewis acid, auto hydrolysis or carbon dioxide and sulfur dioxide. These are the acid treatment. And solvent extraction also available, or organosol, molten salts, ionic liquids, supercritical solvents, and oxidation processes, wet oxidation, par oxidation. These are all the methods are available for a biomass treatment for further converting to soluble sugars and then to produce bioethanol. So in actual practice, what are the main steps? What are the main steps available for producing biofuels from the material? So I just want to discuss a, a a scheme where you will have a little bit what more precisely you can see that if you take a wood chips or wood pellet, what is the structure? The lignocellulosic material is structure is like this one. That this green part is cellulose, and it will covered with the hemicellulose, and like this red like ribbon like red ribbons that will bind the cellulose and hemicellulosic material by the lignin. So during pre-treatment, what will happen? This defragmentation take place. Defragmentation means you are means, breaking the bonds of lignin and cellulose and hemicellulose. So during the pre-treatment, pre-treatment, and then pre-treated biomass you will have, then you need to do hydrolysis of the this pre-treated biomass. Hydrolysis means it is possible by using some enzymes like cellulase. Actually presently only cellulase enzymatic hydrolysis is possible. Some part they are using sulfuric acid for the hydrolysis part, but enzymatic hydrolysis is more favorable from different technological perspectives. And by doing hydrolysis, you are producing glucose or soluble sugars. Actually, cellulose actually is a that polymer of glucose. That why we are doing the hydrolysis part after pre-treatment, that we are producing soluble sugar or soluble glucose. Mainly, we are having glucose from cellulose. If you means if someone is interested on doing this reaction by taking standard samples, then you can just take cellulose and put some cellulose enzyme, then you can convert it the whole cellulose part to the glucose. And this by getting the glucose, that fermentation part by using yeast or acid, you will have the ethanol or bioethanol. So what is the role of the pre-treatment? That actually the pre-treatment and the different types of pre-treatment methods are available. It will deconstruct the lignocellulosic material, and so that the carbohydrate becomes accessible for the enzymatic. So cellulose accessibility. The main question is you need to do the enzymatic hydrolysis part, for further conversion to ethanol. Actually, this pre-treatment, this later two part, hydrolysis part, and from glucose to ethanol, these are all, this technology is already developed by researchers and already it is developed. But this first part, pre-treatment of biomass, it is very much essential to produce cellulose, to make the cellulose of the lignocellulosic material accessible for this what I can say that cellulose accessibility, cellulase accessibility. So these are the some common structural patterns. Actually, I checked it in literature. One journal, one review article published in 2020 in a Chemical Society review. They clearly show lignin cellulose and hemicellulose. So from these actually you can produce from hemicellulose you will have 5-hydroxymethyl perfluoril and perfluoril. These are the building blocks for different different production of different chemicals. Have the if you do the reductive upgrading of these chemicals, then you will have different hydrocarbon feedstocks. So during actually this process, some chemicals are produced. These are actually formation of major inhibitory byproducts that is formed during the carbohydrate present in lignocellulose. They are actually hindering the reaction. So when you are going for the process optimization, you need to check whether these compounds are formed or not. If it is formed, if you can remove these compounds from the reaction media, then the production of biofuel will be faster. So that is why actually these intermediate compounds have been identified and isolated from the pretreatment media. And beside hemicellulose and lignin derived compounds, some inhibitory byproducts produced during pretreatment. That is furanaldehydes, weak acids, and hydrolysis derived substances like soluble oligomeric sugars. These are actually act as a inhibitory product for further production of what we can say soluble sugars or ethanol production. So we actually carried out some experiments in our lab in Georgia Tech that we are producing, that we are performing that pre-treatment technologies. How wood pellets, wood chips you can convert it to the smashed pre-treated wood powders. Actually, we are producing wood powders from what I can say hardwood and softwood. Almost all effective pretreatment methods cannot handle large size wood chips directly. For reducing the price of the whole process, you need to if you reduce some of the process, then you can reduce the cost of the final product. So what we did that we are taking the wood chips, not in the wood powder. Most of the literature, most of the people, what they are doing, just they are taking the before going for pre-treatment, they are grinding the whole biomass component. As you know, that it is very difficult to grind wood. It is not like that our vegetables and all. It is very difficult. High energy is required to grind these wood chips. So like big machines are required, crushers are required. So what we did, that we didn't go for that grinding of woods. We are using that wood chips directly. Just we are cutting in small pieces and we are treating with ferric chloride, sodium nitrate, and oxygen. Oxygen pressure is around 10 bar and temperature is around 100 degrees centigrade. For the first time, actually, we have reported this work from Georgia Institute of Technology, that how low temperature and low pressure method can be used for the production of soluble sugars from wood chips by pre-treatment method. What we did, we just using this catalyst, we are putting in autoclave. As you seen here, that autoclave, you can just inject oxygen gas from outside from the cylinder, and this is a temperature controlled autoclave that we are doing the reaction at 100 degrees centigrade, and after 2 hours we'll have this wood powders. And after that, getting the wood powders, we are doing the reaction, enzymatic hydrolysis reactions, to have soluble sugars. This is like golden yellow color, light yellow color soluble sugar we are getting, and after that you can convert it this soluble sugar to ethanol molecules by using yeast as an enzyme. So here the process is that here actually we are using very small amount of the catalyst. Small amount of catalyst means we are using for 100 grams of the wood chips, we are using only 25 milligram to 40 milligram of catalyst. Means we are using very small amount of ferric chloride. Ferric chloride, actually Fe3 plus, is responsible for ferric chloride. The oxidation state of iron in ferric chloride is 3 plus, that is 3 electrons are removed from the iron metal. And when we treat these wood chips with ferric chloride, the oxidation state of Fe3 plus is converted to Fe2 plus. And we are using, when we are using means that 10% of the total means sodium nitrate, it will again convert this Fe2 plus to the Fe3 plus, means we are regenerating our catalyst during the process. Means this Fe3 plus is responsible for the pre-treatment process of these wood sieves, and after pre-treatment this Fe3 plus is converted to the Fe2 plus, and again by using sodium nitrate means that Fe2 plus is again converted to the Fe3 plus, so that the process will continue. So that is why we are using very small amount of the catalyst. We are using very what I can say, low high oxygen pressure and low temperature. So so these are actually the basic schematic actually we presented in our work, that how it will ferric chloride is responsible for defragmentation of the wood chips to cellulosic fragments and dissolved fragments. Actually, these are the schematics we presented in our research findings. So for this, if you looked at the pre-treatment, pre-treated wood chips, these are actually they're hardwood, and in hardwood and softwood, chemically softwood is very difficult to defragment, because it is more tightly bound. Lignin is more tightly bind with the cellulose and hemicellulose. So these are the hardwood photos. Without our catalyst, after 2 hours, we do not have any changes of the wood chips, as we have seen from the figure, this A and B figure. But when we use our catalyst, it will smashed out. Means we are having that almost powder, means powdery wood material after pre-treatment. So these are the optical microscopic image of pre-treated woods by using ferric chloride, sodium nitrate, and 10 bar of oxygen pressure. And this is for this second figure is for the soft tools. Without the catalyst, there will not be any change, and if we use our catalyst, ferric chloride, sodium nitrate, and oxygen at 100 degrees centigrade for 2 hours, will break all the bones and making means powder like material from the wood chips. And these are the figure D is the what I can say, that optical microscopic image. So after that, what we did after getting that pre-treated wood, actually we are converting our pre-treated wood to reducing sugars. So these are the conversion rates. Actually we are not getting means actually we are, for hardwood we are getting 71.56%, and for softwood it is 70.66. Since the percentage conversion of this soluble sugar from the pre-treated woods is less in case of softwood, since and not less, actually it is very similar, but still you can say that due to the means strong binding of the lignin with the cellulose and hemicellulose in hardwood, actually the results of this cause of this result. So we studied different weight percent of different catalyst systems, and we are having different times, 60 minutes, 90 minutes, and 120 minutes, up to 120 minutes reactions for 2 hours. And then we studied the temperature effect. 80 degrees centigrade, it is like 20 to 30% conversion of wood chips to the soluble sugar. And then if you increase the temperature to 100 degrees centigrade, then we will have around 70 degrees centigrade. But if you increase the temperature up to 150 degrees centigrade, then it is again goes down the reaction. And for similar results also we are getting for hardwood also. These are some of the results for which actually we say that we can claim that our pre-treatment process is very effective, since we are using very less amount of catalyst, less amount of oxygen pressure, and we are doing the reaction in means low temperature as compared to the other methods available at that time. Actually we published this paper in 2016, and for this actually we did lots of characterization techniques we used for the establish our research, and we did the infrared spectroscopy, we take the help of infrared spectroscopy and scanning electron microscopic analysis of the wood chips before and after the pre-treatment. How the surface is changed after pre-treatment. You can clearly see the figure from the B that after the pre-treatment that the surface morphology is changed, and these are the some morphological characterization to establish our research. And finally, what we did, we did the thermogravimetric analysis for pre-treated and raw hardwood and softwoods, and TGA-DSC showed actually very nice results, as well as XRD also we are having that for crystallinity analysis of the if there are any signs of crystalline nature of the wood particles after pre-treatment. We checked it then whether the cellulose is intact after the pre-treatment process. We confirmed from our XRD analysis that whatever peaks actually for cellulose 1 and cellulose 2 we are getting for untreated and pre-treated, it is same, means we are not there will not be, there was no any change in the cellulose crystalline nature or cellulose accessibility. So after that we studied the X-ray photoelectron spectroscopy. These are actually, that time it was in 2016, X-ray photoelectron spectroscopy was very new to me. Actually that time I spent lots more time on that, but during my staying at Georgia Tech, we have 2 machines of X-ray photoelectron spectroscopy. That time I have the opportunity to analyze this actual chemical structure of the wood particles before and after the pre-treatment process we analyze. But nowadays in our region, NIST Jorhat has one what I can say that X-ray photoelectron spectroscopy. Actually we are assessing from them only, and for this region only one presently we'll have only one X-ray photoelectron spectroscopy. So these are very interesting analytical tools to describe or to analyze the surface, chemical nature of any particles. I'm just skipped, and this paper, low temperature, low energy, and high efficiency pre-treatment technology for large wood chips with a redox coupled catalyst, we published from Georgia Institute of Technology. This is my first paper of my postdoc research that we published in chemistry, sustainable chemistry. That journal is published from Wiley Publications. So next part, am I audible now? Everything is going well?
Yes, sir.
So next part, before going for this lignin part, I just want to have a brief discussion about the lignin. What is lignin and what is the role of lignin, as I discussed in the previous slides. But what is lignin, I wrote is clearly linker between cellulose and hemicellulose, improve mechanical strength, good barrier to water penetration, and abundance is 20 to 30% of the dry mass of woods, and production 50 billion tons per year annually. So an application, if you look at the application till now, that over 90% is burned for heating directly, and even in NRL Numoligo refinery, they are having, they are setting up of biofuel plant, bioethanol production plant. They are also planning to burn their lignin part to produce heat and electricity. So in NRL they are going to produce bioethanol from bamboo. So this technology actually they are taking from Finland, I guess. So these are the present scenario that 90% of the lignin is burnt for produce heat, and that presently researchers showed that from these value-added applications, liquid fuels, carbon fibers, and composites and aromatic chemicals you can produce from the lignin part. So this is a very common slide. Just I will skip this one, and this treatment methods of lignin. So there are different treatment methods are available to produce chemicals and other like materials. If you defragment it, depolymerization of lignin is one of the important research in the present context. You can do the polymerization of lignin by different methods like pyrolysis. Pyrolysis means thermal treatment, no oxygen without catalyst. Pyrolysis is a method where without oxygen you are heating the um, heating the material. So there you can produce solid SAR, means biosar. That is one of the very important carbon containing compound you will have. Pyrolysis oil. From this pyrolysis oil, you can directly convert it by hydrodeoxygenation of this pyrolysis oil. You can produce directly that hydrocarbon fuels. And hydrogenolysis, that this is also hydrogenation technique, thermal treatment with hydrogen and liquid monomeric phenol. Phenolic compounds you will have once you depolymerize lignin by using hydrogenolysis. Then the third one is oxidation process, thermal treatment with oxygen. If you hit your lignin components by using oxygen, and if you are heating up to more than 200 degrees centigrade, or if you are hitting different temperatures, you will have aldehydes, vanillin and pyrangyaldehyde. Actually, we later on with our catalyst, iron oxide, ferric chloride, sodium nitrate process, we defragmented our lignin, means craft lignin, and we are producing vanillin and vanillic acid. That the major products we have. And actually this vanillin and vanillic acid production we reported in a journal called Fuel in 2019. And then gasification. Heat solid lignin breakdown, biogas, hydrogen, carbon monoxide, carbon dioxide, and methane you will have, and then combustion with oxygen, it will produce heat, gases, and solid SAR. So these are the possibilities of having lignin, means having chemicals from lignin by depolymerization method. So actually there are some different kinds of limitations. Different limitations are here. Why this lignin part you cannot convert it directly to what I can say that directly evaluated chemicals? There are lots of issues. Issues means if you heat it in presence of water, then what will happen? Or in presence of methanol, it will repolymerize the chemicals that you that converted from lignin. Repolymerization takes place, and again it will form the polymeric components. So that is the main issue, that limiting compatibility and solubility. It is not, lignin is not soluble in water. That is one issue. Lignin you can have the solubility of lignin in basic conditions, sodium hydroxide, sodium sulfide, or any other bases, and tetrahydrofuran is one of the solvent that you can use for solubilizing lignin. So these are some of the issues: solubility, and then it contains lots more hydrophilic functional groups and oleophilic backbones. So for that, actually we have modification of the functional groups present in the lignin component. The modification you can do by esterification, acylation, nitration, halogenation, alkylation, and sulfonation. These are like basic organic chemistry reactions that you can have modified lignin by using these reactions. For this part, actually pure organic chemistry is required. Actually, I'm not able to carry out such kind of reactions in my lab, since very other setup is required. So challenge is lignin depolymerization to aromatic monomers. Ester bond in lignin structure. That one ester bond is there, beta O4 bond. That is for that, actually lignin structure is very complicated, and it is very difficult to have some stable monomers from this polymeric lignin. So here actually I show some what I can say that summary of procedures for isolation of lignin from lignocellulosic biomass. So here, if you looked at the summary of procedures for isolation of lignin, if you took any lignocellulosic material, then if you use 72% sulfuric acid for the solubilization of lignin, then lignin is called Carlson lignin. And Carlson lignin actually, in every method, you'll have some advantages and some disadvantages. So based on your requirement, you can fractionate your lignin part component from the biomass. That is, what kind of materials or what kind of chemicals you are going to produce from lignin. Based on that, you can choose these methods, whether which one is applicable for you. So if you use sodium sulfide in sodium hydroxide, then you will have craft lignin. That actually, in general, most of the cases people are using by craft lignin, since 72% sulfuric acid is very corrosive, and special actually setup is required to heat the liquid material sulfuric acid. Lots more, the reaction is very exothermic, so you need to have a very standard setup for this experimentation, Carlson lignin. And what people are doing, mainly people pressing this one, craft lignin production by using sodium sulfide and sodium hydroxide. And sulfide or bisulfide also you can use for the defragmentation of lignin from the biomass. That lignin is called sulfide lignin. And directly you can use sodium hydroxide for separation of isolation of lignin from the biomass material, that is called alkali lignin. So these are these are the methods actually available. Why actually this part, that Carlson lignin, craft lignin, sulfide lignin, and alkali lignin, during these 4 processes, significant structural modifications takes place. Means you are using harsh reaction conditions from to isolate lignin from the biomass material. But later part, what scientists are looking for, that if you have the same chemical structure after the isolation of lignin, whatever it is as such in biomass, then people are looking for different methods. People are using for organosoluble lignin, means organic solvents, people are using organic solvents like methanol, ethanol, acetone. They are using for isolation of lignocellulose. But in every process, after isolation, means from the liquid media, it is very difficult to precipitate the lignin. That is the main issue. That different methods have been used, like solvent extraction or membrane filtration process have been developed, but still it is in primitive stage. Now, milled lignin, extensive grinding and solvent extraction. So for this process, you need to grind the whole lignocellulosic material to find post particles, and then you do the extraction. Then cellulitic enzymes plus solvent extraction. Some enzymes are they are like lakease, that oxidoreductase enzymes are available. Lakease or polyphenol oxidase, they are using for that cellulitic enzyme extraction of lignin from the biomass material. And ionic liquids. These ionic liquids nowadays plays a major, very interesting role, but due to the cost of the ionic liquid and due to the cost of the enzymes, these 2 methods are like very expensive. So if someone is interested to have our indigenous enzymes, if someone is extracting the enzyme or making ionic liquids in their own lab, so that you can reduce the cost of the lignin processes. Actually, I put this slide from one thesis called Shu. He is presently working in National Renewable Energy Laboratory, Golden, Colorado. He is working on oxidative fractionation of craft lignin and organosoluble lignin, different chemicals. Right from his thesis part, he did his PhD from Renewable Bioproducts Institute and Chemical and Biomolecular Engineering, Georgia Institute of Technology. He got the PhD in 2019. I took this slide from his thesis part. So lignin fractionation, the 2 parties there. First, lignin means that isolation, then the lignin fractionation. Once you have in these methods, lignin you can isolate from the lignocellulosic material, and your lignin, your every lignin is in your solution part. So how you are going to precipitate or separate the lignin part from your solution media? For this, actually different methods are available. So first one is pH control. If you are extracting your lignin by using some sodium hydroxide or sodium sulfide, and if you are putting if you are reducing the pH of the solution, then you can precipitate out from the precipitate lignin from the reaction media. And then solvent water extraction, that partial solubility in different ratios organic water solution. If you decrease the polarity, then you will have lignin precipitation takes place. And then solvent extraction, partial solubility in organic solvents. So for that, actually alcohol, chloroform ethers, and DMSO, dimethyl sulfoxide, dichloromethane, tetrahydrofuran, hexane, and ketones are used. And number 4 is ultrafiltration methods. So these are the physical filtration methods. For that, you can use ceramic filters or polymeric filters. Both you can use for the isolation separation of liquid from the reaction media. These are the 4 methods available, but these 4 methods have some advantages and some disadvantages. But we are looking for, the scientists are looking for some easy methods so that you can fractionate and isolate lignin from the reaction in a better way. So this is the fractionation of by organic lignin by organic solvents. These are the methods. If you are, say, suppose you are dissolving lignin in 60% acetone water, volume by volume, means you are using 60 ml acetone and 40 ml of water in your as a solvent system. And if you are reducing after extraction, if you are reducing to means dilution to 52% of acetone, then fraction will come out. And if you still you are reducing the dilution of acetone, means you are reducing the percentage of acetone in your solution, then again another part will come out. So this way, like if you reducing the organic part from your solvent system, you will have the fractionation of the, what I can say, that fractionation of that lignins from solutions. So here another method is there, gel permeation chromatography. It's like very similar to column chromatography, but here people are using, what they are using, they're like using some granules of molecular sieves they are using, and they are separating different fractions of the different fractions of the, what I can say, that isolate the different fractions from the reaction media. This is gel chromatography. Chromatographic means instrument that is very similar to high performance liquid chromatography. I'm not going details on that. I'm just showing that what are the methods available. And number 4 is membrane filtration methods. By using different ceramic and polymeric membranes, you will have different isolation. You can isolate different fractions of the different molecular weights of the lignin fractions. So these are precipitation by using this is very common actually in our level. So we are working on that. That how the how you are decreasing the pH of the solution by using acid to precipitate lignin from your reaction media. So from these, actually, we conclude that fractionation of lignin into low molar mass components can be used for development of value-added products, such as platform chemicals, increased profitability of lignocellulosic and lignocellulosic biorefineries. It can highlight it that despite the advantages and disadvantages of one method in relation to others, the choice of particular process will be dependent on the objective to be achieved. Means what kind of material, what kind of chemicals, what kind of fuels you are going to have. Based on that, you need to choose your lignin fractionation and isolation methods. So next, I want to discuss about the depolymerization of lignin. So for depolymerization of lignin, different methods are available. So what we are doing, that although the fundamental research has historically focused on converting lignin to chemicals, very little effort has been translated into commercial factories. So Different methods means lignin dissolution, biological methods by using enzymes, thermal disruption means catalytic cracking or hydrolysis, reduction means heterogeneous catalysis by using means non-conventional hydrogenating metals, or transition metals can be used for heterogeneous catalysis, homogeneous catalysis, and electrocatalysis. And for oxidation also, heterogeneous catalysis, we are interested in homogeneous catalysis and electrocatalysis. For homogeneous catalysis, we are using polyoxametallase based catalyst and iron oxide catalyst. So development of techniques to produce aromatics from lignin is not only urgent and challenging, but also a visible long-term opportunity. So what we did in our lab means, for our second project, we did we are taking the craft lignin, and in presence of we are using the catalyst of ferric chloride, sodium nitrate, and in oxygen pressure at 100 degrees centigrade. We are having the vanillic acid, syringic acid, and 4-hydroxybenzoic acid. After this depolymerization method at 100 degrees centigrade in presence of 10 bar oxygen pressure, in presence of ferric chloride and sodium nitrate, we obtained 4-hydroxybenzoic acid, vanillic acid, and syringic acid. And this actually, this process actually, we tried to produce vanillin, but since we are actually unable to the control this part, that vanillin to vanillic acid conversion. This is actually after vanillic acid can be converted to the vanillin can be converted to the vanillic acid by oxidation process. This step we are not able to control this reaction. Actually, we supposed to have vanillin from lignin, but finally we have the vanillic acid. So actually, during our publication time, when we report this method for publication, that most of the reviewers, they are asking that why you are not able to control the reaction. So it is very difficult. Actually, we had that time we had a very less time, because I moved for a I stayed only 1 year. So that is why actually we are not able to further analysis this compound. But still, we are able to publish this paper in a 90 years old journal called Fuel. So based on these are some of the experimental parameters we studied, that how actually we are getting, that how much conversion we are getting. That actually we for craft lignin at 100 degrees centigrade for 2 hours in presence of ferric chloride, sodium nitrate, and oxygen pressure, we'll have 79.15% conversion we have. And that actually conversion we quantification we did by HPLC analysis by using that standard curve method. So we actually, one way we are successful to produce 3 components from the lignin, but after that we separated the components to individual components. But for that actually we need to go for another membrane technology method, but still work is going means further conversion to different means chemicals. So these are the some of the SPLC chromatogram, that how we quantify and how we justify our result, that how we are getting the peaks of SPLC in different regions. So these are the SPLC chromatogram in methanol and water, that we are getting vanillic acid, syringic acid, and 4-hydroxy benzoic acid. So again, for this part also we did extensive characterization by using XPS and other analytical tools, and we established our research that we are having these 3 chemicals we have in our system. So this article we published in Fuel in 2018. So next, what we did that we are means looking for that some kind of methods by using that directly how we can produce lignin bio oil or other phenolic monomers. So we studied the lignin depolymerization by using polyoxametallate catalyst. Polyoxametallate catalyst also, it is very interesting type, that how we are having that chemicals from lignin. So these are, we actually, for this we analyze our components in gas chromatography. So since we are getting lignin, oil, and different chemicals, actually that we did lots of extensive studies, we lots of did analytical lots of analysis we did, and finally we will have different components. But these components, it is very difficult to say isolate these compounds, that amount is very less. For some compounds amount is very less. We stopped this work and we published this work in 2021 in SCS Sustainable Chemistry and Engineering. So another method we applied for what I can say, that the lignin first approach, how we are getting the chemicals and fuel directly from the lignocellulosic biomass instead of using lignin. So here lignin first method is like that, we are going to have chemicals, lignin chemicals from directly biomass. So lignin, we are during the pretreatment method, we are trying to have the chemicals in the same step, one step. So step 1, the lignin fractionation with polyoxametallate oxidation and methanol under mild conditions. Actually, our research focuses on the mild reaction conditions, not using harsh reaction conditions. Means we are trying to have chemicals in a very sustainable way, so that if your temperature rises to more than 200 or 300 degrees centigrade, then you will have different setup for your reaction. So what we are planning, we are that chemically how we are converted our lignin part or carbohydrate part or hemicellulose part to useful chemicals at low temperature. So second step is that depolymerization of isolated lignin with polyoxametallate. Actually, we are using two-step method but in a single pot. So here also we have different components. We are having syringaldehyde, methyl vanillate, methyl syringate, vanillin, and here we are by this method we are able to have 8% of the vanillin instead of vanillic acid. In the last work, what we did, we are not able to control that oxidation reaction, and vanillin is converted to the vanillic acid. But here 8% vanillin we are having by using this mild reaction conditions, using polyoxametallate POM as a what I can say, that oxidizing agent. So this is the GCFID spectrum of lignin oil by lignin first strategy with yield of monomers and dimers, and it is 5 major monomers we have. These are 5 major monomers, means as syringaldehyde it is 12%, methyl vanillate 10%, methyl syringate 15%, and vanillin 8%. So these are the works actually we did for our that 1 year work. So another concept recently added by the scientific community, that how you are converting your biomass to hydrocarbon fuel. So if you looked at the methods that is available, it's a little bit different. That we are initially what we are having, that we are using that we are doing pretreatment for the production of bioethanol. We are using lignin, isolate the lignin, and we are converting to the phenolic monomers, and then we are having different chemicals. But here one strategy, direct strategy, means scientific community has put that if you are producing hydrocarbon fuel by using lignocellulosic biomass, and lignocellulosic biomass derived bio oil is a potential next generation fuel and has energy density higher than that of biomass itself. The bio oil is produced by the decomposition of polymeric biomass into small molecular oxygenates such as aldehydes, ketones, carboxylic acid, and phenols. Using these, actually, we'll have lots more chemicals, more than 300 small molecules will have, having the functional groups of phenols, aldehyde, ketones, and carboxylic acid. Here, actually, the oxygen content in bio oil, actually, bio oil is produced by the pyrolysis of what I can say, the pyrolysis of lignin, or pyrolysis of the lignocellulosic material. So these are the here the oxygen content is pyrolyzed high, and upgrading is necessary. Why it is upgrading? Due to the presence of oxygen molecules, higher oxygen molecules. It's you need to remove the oxygen containing functional groups or compounds from the bio oil. So this can be achieved by hydrodeoxygenation. One process, hydrodeoxygenation, that is called catalytic hydrodeoxygenation, is possible before conversion to the hydrocarbon fuel or chemicals. Means, chemicals, you will have benzene, toluene, xylene, and other hydrocarbon materials. The phenolic monomers from lignin, say in the bio oil, are more complicated to upgrade than water soluble carbohydrate derived fractions. So you will have more than 300 chemical compounds after pyrolysis, and you need to separate it by doing some methods, and you need to do the what I can say that based on the solubility. Suppose carbohydrate fractions, that chemicals you are having after pyrolysis, the carbohydrate fractions, that is soluble in water, and the lignin part is insoluble in water. So you are having two different layers in your solution bio oil, and you can separately you can upgrade both the what I can say both the part. So that fractionation also here, actually, that if you control the fractionation method by a lignin first approach, then also you can restrict some of the unwanted means unwanted what I can say that reactions that is taking place. So here the schematic is that if you take the lignin for pyrolysis in presence of zeolite, in most of the cases, actually, zeolite is being used as zeolite and molybdenum containing or metal containing, transition metal containing that, or noble gas metal containing zeolites, like noble gas like palladium, rhodium, ruthenium. These are very good catalysts for hydrogenation for long time. So these are the chemicals used for this pyrolysis, and once you have the pyrolysis, and you have this kind of phenolic compounds, and this in a second step, by using the same catalyst, you can convert these oxygenated molecules, that is phenolic compounds, to the hydrocarbon fuel. This is one like here also catalysts like platinum, palladium, and ruthenium, nickel, and molybdenum, etc. They are using. So here actually some days ago, one article recently published, that how heavy oil you can convert it to the hydrocarbon fuels. So these are in color, the dark brown color of heavy fraction bio oil. You will have, once you do the pyrolysis, then you will have a heavy fraction of bio oil. So in dark brown in color, and this fractionation, after the fractionation, you will have different phenolic compounds, and after means that upgrading of your bio oil, you will have a light yellow, like light yellow color means hydrocarbon fuel you will have, then structural penalty like this. So here actually they are using ruthenium, and ruthenium supported on alpha alumina catalyst they are using for both the processes. So it's very interesting, and I hope that this method also will have can meet at least from some future perspective of the scientific community. So here also another method by using zinc chloride. Zinc chloride solution means that lignin they are converting to the means, by degradation process they are using having some phenolic monomers, and then coupling with hydrodeoxygenation reactions to cyclic and means that long chain what I can say that hydrocarbon feed we are getting by using zinc chloride solutions. So actually for this bio oil production and bio oil upgradation, these actually some part some part of the United States, their industrial process they have developed by using bio oil conversion to the hydrocarbon fuel. So this is the basic structure of a biorefinery, where you will have hydrocarbon feed from the biomass counterparts. So here the hydrocracker is there, so you are going to feed the renewable feedstock here, and you will have hydrogenation reaction, and means in terms of hydrogen you can do the process to have bio oil. In the second column, the hydro deoxygenator, you are going to reduce the oxygen content from the your phenolic compounds, and then you will have C3 to C4, that is LPG, naphtha, C5 to C9, and jet fuel, C10 to C15. Actually, from bio oil to aviation jet fuel, it is very important, and most of the people like institutions like Massachusetts Institute of Technology, University of Tennessee Knoxville, and the University of Wisconsin-Madison, and maybe the group, they are working on the aviation jet fuel components from biomass. So these are some of the what I can say advancements going on in the present scientific community, from biomass to fuels and chemicals. So up to this, if someone has some questions, then you can ask me any doubts up to this part. So next part, I'll go for the fuel cell part. Before going to the fuel cell part, I have some questions from the participants.
Thank you, sir. The participants, if you have any queries or any questions, you can unmute yourself or you can write it in the chat box.
Okay, so I think I should move to the next part. That this is actually very interesting, and from biomass to electricity. So from biomass to electricity, as we know that these are very interesting. That how biomass can be converted to the electricity and hydrogen. So as we have discussed in the previous slides, that biomass contains large amount of hydrogen elements. So they are also great sources for hydrogen production. So biomass-based flow fuel cell technology to directly convert biomass to electricity, and using electrolysis technology to convert biomass to hydrogen at low temperature are two new areas having attractive great research interest recently. So till now, the main technologies available for biomass to electricity or hydrogen production is that common technologies are that steam turbine generators, high temperature biomass fuel cell, microbial fuel cell, and concept of low temperature biomass fuel cell. These are the very common technologies now available, and people are working on that in different parts of the globe. So for most common technologies for biomass to hydrogen, there are also gasification methods and reforming, microbial approaches, concept of low temperature electrochemical approaches of biomass to hydrogen production, and low temperature electrolysis biomass to hydrogen. So these are the some common parts of the biomass to electricity and technologies people are working on in scientific community. So I'm going to discuss about some very interesting flow fuel cell. That is, what do we mean by flow fuel cell? In most of the cases, that fuel cell means, that what is the role of a fuel cell? A fuel cell produces electricity from chemical energy with a much higher conversion efficiency than traditional thermal conversion based on turbine driven. So fuel cells that is actually that here, yeah, this flow fuel cell, actually this fuel cell in 2014 that the Professor Ewing they invented this flow fuel cell. This is a very new kind of flow fuel cell, that fuel cell that they are using the two extra means extra solution for using the extra part they are using for producing the electricity from the biomass. So they are using solar induced. Solar means that solar, as we know, that if you are incorporating solar part, then you are producing some kind of that electron sources to the system. So solar in this hybrid fuel cell for the first time that utilize uh, uh, polyoxymetallate as the photocatalyst to oxidize different biomass at anode. O2 was used as a final electron acceptor at the cathode under the catalysis of platinum carbon in this case. Means here they are using for oxygen reduction, they are reducing the oxygens and by using platinum carbon catalyst, and they are using means that polyoxymetallate as the other part of the system. So they after that Liu et al. From the same group build a completely noble metal free POM catalyst mediated fuel cell based on this based on the previous research. They actually invented this polyoxymetallate without having a noble catalyst. Here, if you looked at the polyoxymetallate, they are using POM1 with biomass and POM2 and oxygen. Okay. So they are doing the reaction, oxidation reactions, and in one part, and they are doing the means uh, recycling of the catalyst by using oxygen reduction. So this process, actually cyclic process, redox process, they are using for this redox process, they are using very small amount of the catalyst. In this upgraded liquid fuel cell, POM are also introduced to the cathode instead of noble metal catalyst to transfer electron to the oxygen. So based on this new design, biomass oxidation and oxygen reduction were catalyzed by two kinds of POM and solution in anode. So high power density has been obtained by using a raw biomass as fuel cell without the treatment or purification. So in other part, other biomass fuel cells, uh, in means previous part of this century, what people are using, they are using some standard symbols like glucose, means carbohydrate sources, glucose or fructose, any carbon means that chemicals they are using for converting to the electricity and hydrogen. But for the first time here in Georgia Tech, they are using directly, they are using biomass, from biomass to electricity. For this, actually they have invented this technology, flow fuel cell technology, and they have dedicated to this scientific community, and they published these two papers in energy environmental science, and one is energy environmental science, and second one in angiochemy, angiochem catalyst, published by, one is published by Wiley Publications and one is published by the Royal Society of Chemistry. So after that they how means that POM can be used for biomass. They use different mechanism they have developed, and biomass and POM they means converting oxidatively, they are converting to oxidized products, carbon dioxide, and reduced POM, reduced catalyst, and then anode what will happen, and they will produce the electrons, and in cathode they are having the electrons, and it will produce the hydrogen in the cathode. Cathode they are producing hydrogen, and they are means by oxygen reduction they are producing electrons in the anode. So these paper also they have published in 2016 in Energy and Environmental Science, published by Royal Society of Chemistry. So these are up to this like I want to discuss today, that how that lignin and biomass can be converted to the means that fuels and chemicals. Here actually we emphasized on the redox couple catalyst. We conclude from conclusion part, I can say that the redox couple Fe3Cl and sodium nitrate effectively pretreated hard and softwood shapes for enzymatic hydrolysis, and this system can be used for hard and softwood pretreatment in the production of soluble sugar for successive production of ethanol. And depolymerization of lignin have value-added chemicals, but there are lots more challenges in terms of energy efficiency, conversion efficiency, separation, and purification technologies. And for electrochemical lignin conversions, commercial lignin conversion and using electrochemical method is still unavailable. Many advantages, but there is still a long way to go to achieve an economically feasible and scale up electrochemical lignin conversion processes. Actually, here lots more work to do in catalysis part, because for any kind of hydrodeoxygenation or any kind of catalytic process, you need to develop a catalyst. Still, people are using the noble metal catalyst, or means that earlier catalyst system. They are trying to have some kind of good catalytic systems based on their research. But people, the material scientists, still looking for the different kinds of to develop different kinds of the catalytic systems which can directly convert the biomass to the electricity. So in conclusion, I can say that the development of effective method for biomass to biofuel and chemical production will boost up the biorefinery concept in particular, and to the total energy scenario of any country in general. So up to this, after that, I would like to thank, next I would like to thank the organizers of this FDP, Professor Subrata Gogoi Madam, who happens to my teacher in my days in DibrUgarh University Petroleum Technology, and Dr. Ranjan Phukon, coordinator of this faculty development program, recent trends in upstream petroleum technology. He happens to my senior, one best senior in DibrUgarh University Petroleum Technology, and I would like to thank really to have a kind of sessions here and include me for giving me an opportunity to share my knowledge, share my recent research to the August audience. So I would like to thank again my Professor Yulin Deng, Georgia Institute of Technology, Professor Xingliang Liu from Guangxi University, Nanning, China, Dr. Aniruddha Gogoi from IIT Guwahati, Dr. Madhukar Navagiri from Maharashtra, Shu from NRL Golden Colorado, Jayanta Sharma from Kaziranga University, Zhongwang Kim from Korea, Yangam University, Dr. Mallesh Beti from Gitam University, Hyderabad, and lastly, my PhD students, Sistri, Yonga, Rishikesh and Rahul Kemprai, for helping me for preparing these presentations as a whole for this. So thank you, and this is my professor. This was my group in United States, and this is Renewable Bioproduct Institute, Georgia Institute of Technology, and is all about the biomass conversion to fuel. Thank you. Over to you, Ranjan Phukon.
Yeah, thank you, Dr. Pariksit Gogoi, sir. Thank you so much for the nice presentation. Any queries from the audience?
Okay, I understand that during these faculty development programs, actually during the second half after taking lunch and all, it is very difficult to have like this, but still, if you have any questions, and you can put in my mail, drop in my mail that you have any questions. So thank you.
Yes, thank you very much. So on behalf of everyone present in this program, I want to thank Dr. Pariksit Gogoi, sir, for his informative and interesting presentation on the important topic of biomass conversion into chemicals and fuels. So we appreciate for sharing us with your knowledge and expertise. So once again, from all of us, thank you so much.
Thank you. Shall I answer the presentation?
Yeah, sure.
Okay, thank you.
Now there will be a lunch break. So we'll assemble here at again 3:45 p.m. So the next session begins at 3:45 p.m. Please join us again.
This conference will now be recorded.
Am I audible?
Yes, I'm making you the presentation.
Sorry.
Yes, sir, your screen is coming.
Okay.
Welcome again. This is the last session of the FDP. It gives me immense pleasure to introduce our esteemed resource person for this session, Professor Jitendra Sanghwai sir of IIT Madras, who is going to talk to us on the topic of advances in oil and gas industry from conventional and unconventional resources. Dr. Jitendra Sanghwai sir, Department of Chemical Engineering at IIT Madras. He holds MTech and PhD in Chemical Engineering from IIT Kanpur and IIT Kharagpur and IIT Kanpur respectively. Professor Sanghwai worked with Schlumberger for a brief period before moving to academia. Professor Sanghwai's research interest lies mainly in the field of gas hydrates, enhanced oil recovery, biology of complex fluid, etc. He has published more than 100 international journal papers and 80 conference publications. Professor Sanghwai has filed 15 Indian patents and 10 international patents. He has graduated 10 PhD students and several master degree students in the field of petroleum engineering. Dr. Sanghwai is the recipient of the Society of Petroleum Engineers Distinguished Award for Petroleum Engineering Faculty of South Asia and Pacific Region 2017. Young Faculty Recognition Award for Excellence in Teaching and Research, and Indian Research and Development Award from IIT Madras 2014 and 17. The National Award for Technology Innovation from Government of India 2016 and 2018. Sri J.C. Bose Patent Award from IIT Madras. 6 Invention Awards from Intellectual Ventures and an SPE Travel Grant Award, SPE Regional Service Award 2015. Recently, Dr. Sanghwai sir has been highlighted as one among the 25 emerging investigators recognized by the American Chemical Society Journal, the Journal of Chemical and Engineering Data, on the journal's cover page and in the editorial of the issue. He also serves as the member of the advisory committee of the Indian Institute of Petroleum and Energy, Visakhapatnam, India, an institute being developed as the Institute of National Importance by the Government of India. So please join me in welcoming Professor Jitendra Sanghwai sir. Over to you, sir.
Okay, I'm audible. I hope so.
Yes, yes.
Because I'm using this particular Goto software for the first time.
Yes.
Good. So, okay. So let us start with my presentation. Thank you for the introduction, Dr. Fukan, and it's my privilege to be, privileged to be happy to be talking in front of all of you. I think this is the second time that I'm giving the talk in front of, as a part of this particular workshop. Now, today I will be touching upon some basics concept and also some advances in the oil and gas recovery from conventional and unconventional reservoir. So we'll see, for next 1.5 hour, some of the aspects that are actually, very important with respect to the recovery of oil and gas. Now, as we know that, oil and gas still remains a very critical commodity for the mankind as far as energy is concerned. So as we know that the war has started, and one can easily see that the oil prices has shoot up drastically to about 150, close to now 140 or 120 barrel. And hopefully, if war continues for long, then the oil prices will again touch to close to 150. So it is very evident that last year somebody was saying, you might have read that data is the new oil, etc. But this year has again confirmed that oil is the oil. So there is no alternative to oil. Well, when I say oil here, I will preferably say in general the fossil fuel, oil, gas, and coal. Now, if you look at in India, we still rely on more than 50% of our energy requirement on the coal, right? And oil and of course gas are important part of our energy basket. So given the fact and situation that at least for next 30-40 years or even more than that, there will be no alternative to oil, gas, and coal. So we have to be ready. I mean, we cannot leave what is there in our hand and run behind something else, which we do not know whether that is will be going to be a very reliable alternative or not in the long run, right? While we venture into new energy resources, we cannot get away with existing energy resources. So there should not be like some kind of negligence on what we should do as a part of increasing our oil and gas, requirement for next few decades, or at least 5 to 6 decades, I guess. So what I'm going to discuss, briefly on hydrates or oil recovery applications. So at IIT Madras, our research is primarily focused on basic few areas, which are on hydrates, enhanced oil recovery, and flow assurance, where we touch upon different areas of gas hydrates, where we talk about natural gas storage, uh, and also we look at flow assurance perspective, and also we look at hydrate as a energy resources. I mean, how the methane can be recovered from hydrate reservoirs. So these are some of the focus areas for hydrate. And in enhanced oil recovery, we are looking at various applications of nanotechnology for oil recovery applications, and also we are looking at, we have already done some studies on microbiology and microbial UR, and in addition to that, we have looked at the impact of some kind of novel green solvent for enhanced oil recovery. And while we do that, we look at different areas of subjects matter that we really use for addressing some of these challenges, as shown here, right? And going forward, before we understand the importance of oil and gas, we should understand that how the energy consumption looks like by different region and sector. So the different areas in the world, as shown here, indicates that the energy consumption, particularly when you talk about billion ton of oil equivalent, it shows that energy consumption will going to grow increase over a period of time, right? And consumption by sector also will rise. Now, even if you talk about electricity share, the electricity should come from some of the resources that we talk about. It can be hydro, it can be nuclear, it can be even fossil fuel, etc. And it can be renewable, right? So overall, all the sectors, we can see that whether you talk about industry, electricity, or transportation, it will increase over a period of time, right? So energy will increase, and so is the consumption of the fuel. So overall, you see, combinedly, oil, gas, and coal constitute significant amount of our energy basket. and we are part of renewable hydro and nuclear. Of course, they are going to grow over a period of time, but one can see that looking at the energy consumption over a period of time, which is going to grow, we cannot possibly compete on renewable or hydro or nuclear. So our dependence on oil, gas, and coal will remain. Now the question is that even if you talk about environment or carbon dioxide release in the environment, I am sure that industry will come up with a carbon neutral oil and gas industry. Particularly whatever you are taking out from the reservoir in the form of hydrocarbon, and how much equivalent of CO2 that you release by burning these fossil fuels will be captured and sequestered back into the reservoir. So these are some of the things that I believe, in next 1 decade, the industry will sustain by its own. The moment it will find the ways to capture the CO2 and make it more carbon neutral. So if you look at the energy supply, projected world energy supply over a period of next 30 or more than 40 years, we are somewhere here right now. So if you look at that, you can see easily that the significant chunk of your energy will come from coal, followed by natural gas. Oil will still go down, but I'm not sure. I don't think so that it will go down that much slow, right? And of course, hydroelectric things will come up, but these will still have to be figured it out where this can be sustainable in the long run, and how this can be, we will have to see that. So some of these aspects tells us that whatever will be the case is, the oil, natural gas, and coal will dominate energy basket, right? Now, if you look at our, the overall energy resources consumption in the world by 2050, these are some of the projections by British Petroleum Energy Outlook 2035. It indicates that significant amount of oil, gas, and coal will drive the market of energy industry. And there are bits of wind and solar and biomass and nuclear and wind, etc. Right? So these will be there, but you can see that these are more almost like a single digit. Right? So the reality is that this is what it is. Right? Now, if you look at India, we can see this is again from the Director General of Hydrocarbon. It shows that the gas demand and oil demand will rise by about 250% and 160% from 2012 to about 2030. Right, and even in India, you see that we have more than 50% coal dependency, followed by oil and gas. Right, so this is the reality, and we cannot neglect the reality as on today. And this reality will remain so given the situation that the kind of geopolitical disturbance affects the oil market or gas market will only tells that we need oil and gas and coal at least to survive, unless we find some reliable alternative in the long run. So from where the oil and gas is coming? The oil and gas is coming from the subsurface reservoir, whether it is onshore or offshore. And you can see that when you talk about these reservoirs, these are present at much lower depth onshore, about 2000 to 3000 feet downhole, or if these are offshore, these are again like 2000 3000 feet below the seabed. And here the high pressure and low temperature conditions, high pressure and high temperature conditions in the reservoir makes are responsible for the high compressible nature of the oil and gas, particularly when these are being drilled, and when they are exposed to the surface, they start flowing from the reservoir to the surface, being they are highly compressible. And it's like a balloon kept in under high pressure and it's trying to explode out, right? So the moment you drill a well, they just find their way from the reservoir to the surface, right? and this oil and gas starts flowing for several years, like for 10, 20, 30, 40, 50, 60, so on and so forth. These oil and gas recovery typically happens in a defined manner, which are primarily defined as what is called as the primary recovery, the secondary recovery and tertiary recovery. So as this oil and gas recovered from the reservoir, in a manner of various stages over the life of a reservoir, the reservoir properties will do typically change. When you talk about reservoir fluid and rock properties, they change, right? And that's where the technology comes in picture to figure it out how the oil and gas recovery can be improved from the reservoir. Now one can see that the reservoir in offshore are located in a more harsh condition, particularly when we try to drill a well in an offshore environment. It's not as easy as drilling a well here on the onshore, right? So you need a very advanced technologies, and the given the situation of highly saline environment in the offshore condition, there are various other issues such as the corrosion, etc. for the facilities, oil and gas production facilities. In addition to that, when the oil and gas flows from the reservoir to the surface to the pipeline through these the ocean environment, the possibility of deposition of wax and asphaltene from the reservoir oil are huge, and therefore in the offshore environment there are a variety of challenges in addition to the corrosion and scale formation. These are primarily with respect to the flow assurance and maintenance of offshore facilities. So a whole lot of interest from the industry is being looked at, particularly looking at how these oil and gas reservoirs are exploited in a very efficient manner from offshore conditions. Right. Onshore reservoirs, of course, have different challenges, but they are less as compared to offshore conditions. And as I told, as I can tell you that we have a lot of oil and gas available still, which can be, if produced, can support our energy requirement for several hundred years, not just 10, 20, 30 years. However, we have to ensure that how we can make it a carbon neutral industry, and that is what the industry's focus should be in next few years. Now, when you talk about energy resources or energy sources, we have crude oil, natural gas, coal, and you have non-conventional solar, wind, tidal, biomass, right? And in unconventional reservoirs, when you talk about unconventional and conventional, the conventional oil and gas reservoirs are easily producible, and they generally become mature, after which we apply enhanced oil recovery methods, right? In unconventional reservoirs, we have shale gas and oil, coal-bed methane, and about waxy and heavy crude oil reservoirs. And of course, significant amount of hydrates are also available in the world, and it has been postulated that with a few percent of recovery can support about several hundred years of gas requirement for the world, right? So these typical information uh, provides you some idea about how the energy resources are classified, primarily in the conventional, unconventional oil and gas resources, and you have a non-conventional solar, wind, tidal, biomass. Now, if you look at the oil reservoirs, one can easily see that significant amount of oil is available in the heavy form, which are primarily the heavy oil, extra heavy oil, and oil sand and bitumen. These all three constitutes about 70% of oil, and the conventional oil represent about 30%. This indicates that past several decades we have been primarily producing oil from the conventional reservoirs, and therefore the significant amount of oil is still left unproduced. And the suitable technologies over a period of time can make them highly economical alternatives for their use, particularly for oil, conventional oil. Now, in any reservoir, so I will touch upon primarily, we'll see whatever I can. touch upon shale oil, shale gas, natural gas hydrate. We will touch upon LNG, GTL. I'm not sure what I can do that. Let's see. So before I start upon, so this tells you that, as I told you that oil and gas is still form a significant chunk of our energy basket. The typical reservoir undergo a decrease in the production over a period of time, and we need to ensure that the growth of oil can be made, demand can be made, and therefore we need a technologies which can support the production of oil and gas from the reservoir. So before I touch upon different aspects, let's understand that there are a variety of crude oil available, in the reservoir, and these are primarily classified from light crude oil to black or brown oil, heavy crude oil, or tar sand and bitumen. This depends. The primarily the oil definition comes upon their difference in the viscosities, which you can guess from these numbers, and the densities, which also you can guess from these numbers. These are therefore defined in different API gravities from about 5 to 45, and 5 represent a heavy oil or extra heavy oil, and 45 represent the light crude oil. Now you can see the the pictorial representation of this condensate, very clear fluid, your brown oil, your heavy crude oil, and your tar sand and bitumen, which is typically very extra in nature, right? So these different types of oil are available in the different reservoirs across our country, and not only that, also in the world, right? And therefore, the solution to recover oil from different reservoir, therefore, does not remain the same for all kind of reservoirs. That will vary depending upon the type of oil that you are dealing with for the recovery. So we'll touch upon some basics of some of these recovery methods. Now, okay, we'll just see. So, what is enhanced oil recovery? So, enhanced oil recovery is a method which is used to recover the oil from the reservoir using a different aids. It can be thermal, it can be chemical, or it can be gaseous, to recover oil from the reservoir when it is no longer very efficient and economical to recover. Right, so any reservoir undergo three primary recovery mechanism, which are defined as a primary recovery, secondary recovery, and tertiary recovery. So in primary recovery, you have 5 to 15% of oil, original oil in place can be recovered. Secondary recovery is about additional 15 to 25% of oil in place can be recovered. And in tertiary recovery, you can recover about 5 to 35% of original oil in place. Now, these recovery methods, can show a different field flow rate. One can see here that as during the primary recovery, the field flow rate increases and start decreasing after some time. Right now, this time duration can be decades, like 20, 30, 40 years, 50 years, 100 years, so and so forth. Right. So these are not us in a month or so. Once you understand that the field flow rates are no longer economical to be produced, you undergo a secondary recovery method. So that means the reservoir undergoes secondary recovery method, in which what you do is you inject the water into the reservoir through the injection way. It can be gas as well, and you try to inject the water and then try to recover more oil from the reservoir. So that is the secondary recovery method. And then this is followed by the tertiary recovery method, where you try to inject some kind of chemicals into the reservoir, which generally be being used to alter the reservoir rock and fluid properties, and thereby you try to increase the recovery. Now one can see that the overall recovery efficiency also increases as you move from primary to secondary and to tertiary recovery methods. Uh, in the absence of secondary or tertiary recovery methods, the primary recovery methods may not provide a high or at most maximum possible recovery from the primary recovery method. So the moment you see that, then you try to improve upon the recovery by means of a secondary recovery methods, and then subsequently you apply the tertiary recovery methods, right? So that's where the recovery efficiency can be increased over a period of time. These methods, therefore, not only improve the recovery of the oil from the reservoir, but they also increase the lifespan of the reservoir. That means the reservoir, which possibly have a life of obviously 50 to 70 years, you can try to improve the life by another 30, 40, 50 years or so, right? So these are some numbers which tells us that how the recovery of original oil in place is possible. Now, what are the different methods available in enhanced oil recovery? So we have chemical UOR method, you have gas flooding, you have microbial, you have thermal UOR methods. As I mentioned you that a different reservoir oil may have a different types of UR methods suitable, and depending upon the reservoir rock and fluid properties, one may try to use suitable UR methods for their application. Now, in a chemical UR methods, you have alkaline, polymer, surfactant, etc. Some of these methods applicable to be used in a reservoir. In a gas flooding, you can use a carbon dioxide flooding, hydrocarbon flooding, nitrogen flooding. Nowadays, a lot of interest has been considered for carbon dioxide injection into the reservoir for oil recovery, and also you can sequester CO2 partly into the reservoir. Microbial methods are used generally for heavy oil reservoirs, and there are a lot of research which has been happening on understanding how the microbes can be used for heavy oil reservoirs, right? Now, in the heavy oil reservoirs, one of the main issue for heavy oil is that it cannot flow in the reservoir, because you can see that these are much viscous fluid, right? And the viscosity, because of the highly viscous nature, even if you drill a well, they do not really flow from the reservoir, in many cases. And therefore, the important task is to first reduce the viscosity of the heavy oil. And the obvious choice here is to use the thermal methods, and where you can use the steam injection, high pressure injection, and so on and so forth. In situ combustion is another method where you can partly burn the heavy oil in situ and try to reduce the viscosity and recover the oil. Microbial methods can also be used for heavy oil, but the issue with microbial methods are that they can form the sludge, and they can block the permeability of the reservoir rock, porous nature of the reservoir rock. However, these are more economical, and if properly managed, they can recover oil from the reservoir as well. So we'll touch upon some aspects of chemical UR methods first, and then some other areas of also. So in chemical UR methods, any typical reservoir, once we talk about, we have the what is called as the polymer flooding mechanism. Now, before polymer flooding, we employ a secondary recovery method where we inject the water into the reservoir, right? So you try to inject the water during the secondary recovery method to push the oil towards the production well. So this is a production well here, and these are the two injection well. You can see the arrowhead going down. These are all injection well. 1, 2, 3, 4. This is a 4-spot, 5-spot injection pattern. So these are 4 plus 1. So one is a production well. Now, when you have this injection well, the oil is being pushed towards the production well through the water flooding. Now, what happens when the oil is relatively viscous? I'm not saying that it is heavy oil, but relatively viscous. The water may form channels, and that is called the viscous fingering. And therefore, due to the viscous fingering, the recovery cannot be achieved at most. And therefore, to avoid that, the polymer flooding is typically being employed, which ensures a proper blanket over water flooding, and that blanket try to push the oil towards the production well. अरे बाप रे, आ जाओ ना. Another 30 minutes. So this oil pushed towards the product is being pushed towards the production well due to the polymer flooding, and therefore the recovery can be increased. Now, this polymer primarily improves the sweep efficiency, macroscopic sweep efficiency, and does not improve the macroscopic sweep efficiency. That means it doesn't really talk about the the pore network in detail. This doesn't really affect the fine pore network where the oil is sitting. So to avoid that, what is being done is to inject the surfactants, which actually helps to reduce the interfacial tension at the reservoir rock matrix, and that surfactant is used, to ensure that the interfacial tension gets reduced, and also possibly it may impact the wettability of the reservoir rock, which can alter the reservoir rock wettability from oil weight to the water weight. So this surfactant slush typically being used at a first step, which is followed by the polymer thickened fresh water, which is then followed by the flood water. So you can see that how the surfactant slush, as it moves to the through the phase zone, the oil get dislodged from the reservoir rock matrix, and then the oil is pushed further toward the production well. Now, the most of this time, the surfactant which is used, sometimes it may also provide you a negative impact on oil recovery if it is not, used properly, selectively for a particular reservoir rock, right? Because it may, without changing the wettability towards the water weight, it may further affect the wettability if it is not compatible with the oil, and so on and so forth, right? So one has to be very careful when we really do these studies in the lab scale. The surfactant can also form some microemulsions in the reservoir rock, and they can therefore provide a better recovery at the surface. Now, as I told you that, I already told you that when you talk about this mobility controlled UR, we talk about viscous fingering. So as I said, like, when you inject the water, it can pass through the some kind of channels, over a period of time. So this is a production well, this is injection well, and that may impact your recovery of oil from the reservoir rock, right? So we use a polymer blanket which help us to push oil more effectively towards the production well, in a very uniform manner, right? So this avoids the viscous fingering impact. Now, let me see if this works. I think this animation is not working. Looks like. I am in the top. What is this? Okay, looks like it's not working. It's working now.
Alkaline surfactant floods or spill animation. The surfactant.
So this is a SDS, sodium glutathione sulfate. This is a surfactant. So generally it has a this is a sulfate surfactant. So it has a hydrophobic head and hydrophilic tail.
Is stuck because it can't get through the pore cells. We introduce surfactants into the system.
Hydrophobic tail and hydrophobic head. So this head goes into the water and this tail goes into the liquid, and they attack on the surface of the oil which is stuck into the reservoir grain matrix. The moment it sits on the surface, it breaks down the oil droplet into the smaller droplet, and as it breaks down, it becomes easy for the smaller droplets to push towards the production well from here.
Once the macroemulsion is formed, the polymer is
so this forms the macroemulsion
to push all the smaller droplets out through the pore throats.
So this water can be then pushed in, which either can be
This way,
polymer solution or it
the
can be a
coupler
water
factors
simply.
seems
So it
like
will pushes the oil
above
towards the production
60%
line.
or very close to the wells, of up to 94% can be achieved.
So yeah, so this is a schematic of how the alkaline surfactant polymer flood happens. Now I will touch upon some work that we have done earlier. Now, as I said, like when you talk about this emulsion flooding or emulsion injection, etc., right? So emulsions are classified in water and oil emulsions or oil and water emulsions, right? And when we talk about this, where we talk about the oil recovery, where the oil which is at you know uh, difficult to push out from the hard to reach pores, like shown here, can be pushed out using some kind of emulsion injection. So you can see that the emulsions, once it is being used, can reach to the areas where only water alone cannot go. So the water just bypass this oil, which is otherwise can be recovered from this rock grain matrix. Now, once we inject some kind of surfactants, they can touch upon these areas and try to recover oil from these hard to reach areas, right? So these are the emulsion typically have a higher viscosity as compared to the conventional UR methods, and therefore they provide a better sweep efficiency, right? So in some of the studies that we have done, we have carried out some studies with respect to formation of emulsions using a nanoparticle, where we use very small nanoparticles, and we have used the polyacrylamide and sodium potassium sulfate, and we form the oil and water emulsions, and you can see that you have a very stable emulsions when we use a nanoparticle. These emulsions which are used using the surfactant polymer emulsions are shown here and are referred to as SP emulsion, and when you use a nanoparticle and surfactant and polymer, these are referred to as a NSP emulsion. So once you use a nanoparticle along with the SP emulsions, you can see that we can form the stable emulsions like this. So NSP emulsions 0.5 to 2 micrometer droplet size, right? Now the idea here is that when you use a nanoparticle, they form the steric hindrance layer along the oil surface, and therefore they don't let it break, for a injection purpose. So these are the emulsions that can be injected into the reservoir, which can be formed at the surface. Now here one can see that the SP emulsions are not stable after 3 hours. They just break down, and the droplet size is relatively higher. The NSP emulsions, when you use the nanoparticle, the droplet size are relatively smaller, of the order of 0.5 to 2 micrometer, right? And they can remain stable for about 3 weeks or longer time. Now, when we use these emulsions for oil recovery methods using the crude oil, so we use oil which has foreign properties, and we got some kind of various sandstone core where you can actually use them into the apparatus to do a recovery studies. What we observed is that when we use these emulsions for oil recovery methods, it has been seen that the NSP emulsions found to be more effective at higher temperatures. We can see at about 360 Kelvin, and so even the clay stabilized emulsions at about 360 Kelvin, these are found to be more effective at providing more than 70 to 80% of oil recovery, incremental oil recovery, as compared to simple SP emulsions, SP floods, right? Now, we can also touch upon some UR methods which are based on carbon dioxide injection. So, in carbon dioxide, the typical process is carried out by injecting, large amount of CO2. So, you can either use the flue gases directly, or you can use a CO2 and mixture of some kind of gases, which can be used to, improve the stability of the carbon dioxide into the reservoir. Now here what happens, the miscible displacement typically due to the carbon dioxide is resultant due to the multiple contact miscibility, MCM, right? And then MCM happens due to the vaporizing gas drive mechanism, where a wider range of carbon dioxide crude oil components get evaporated from C2 to C30, right? And therefore CO2 floods are available, applicable for wider range of reservoir, possibly because the critical point are very less. I mean, the numbers are very less for CO2, and all the reservoirs, the conditions of pressure and temperatures falls well within the supercritical zone for CO2. And it's known that at supercritical condition, the CO2 becomes more highly soluble, or it has a more better solvation properties as compared to any other components, right? So here the CO2 is typically being explored, possibly for UR application. So you can see that the phase diagram of CO2, as I said, the phase diagram of CO2 shows about 300 Kelvin of critical temperature and about 100 bar of critical pressure. That comes to about 1500 psi, and this comes to about 27 degrees centigrade. Most of the reservoirs have a pressure and temperature higher than this critical point of CO2. And whenever we inject the CO2 gas, it becomes supercritical at those conditions, and therefore it's being expected that at supercritical condition the CO2 provides more dissolution properties with the crude oil, and therefore it can impact the viscosity of the oil significantly, and thereby increasing the recovery, right? So these are the multiple contact miscible operations which are responsible for oil recovery. So one can see here in the schematic that whatever oil that is stuck on the grain size, once you inject the CO2 into the reservoir, it gets miscible with the carbon dioxide. And as it gets miscible with the CO2, it not only reduces the viscosity of the oil, but the oil swells out. It just swells. As the oil swells out, it tries to find the way, because it cannot really possibly to sit here. So it tries to find the way, forward to make sure that it is more comfortable. And in that process, what happens? The oil droplets stuck together and form the big chunk. Having said that, these oils still have a low viscosity. It becomes easy to flow when we inject water, which possibly push the oil towards the production well more efficiently. Now, the best strategy for such studies are to actually plan the power plants at a place where we have these oil reservoirs. So that is one of the first strategy to make the oil and gas industry carbon neutral. The strategy is that you generate electricity from the power plant using the oil or gas or coal. Even if you run our vehicle on the electric batteries or electric vehicles, the important aspects that the batteries are not uh, the energy producing devices. These are the energy storage devices. So the battery stores the energy. So you need electricity, right? At the end of the day, you need electricity to charge your batteries. So from where the electricity will come? Even the electricity that we receive at our home possibly comes from nuclear power plant or hydroelectricity power plant, or they may come from the coal-fired power plant, right? So there has to be some resources which are responsible to generate this electricity. So in a recent time, there has been lot of efforts by government to transform the coal-fired power plant to be more carbon neutral, and also generate newer power plants which are more based on the natural gas, because natural gas emits less CO2 as compared to coal also. So in that case, the best strategy is to make sure that you generate electricity where there is a resources available, and then the CO2 that is getting out from this power plant can be captured and can be injected back into the reservoir. So this strategy should be the first step towards making the situation carbon neutral. Now this is a schematic. Again, I will show that to you. So you can see that how the animation depicts the CO2 injection. So it comes from the pipeline to the CO2 separation. So these are the CO2 injection well. These are the production wells. So you try to inject the CO2. and then CO2, as you inject that into the reservoir, you just go there, and these are the trapped oil here. So once it injected into the oil formation, the CO2 injects, the oil swells and just moves forward. So as it goes, likewise, the oil starts moving from the reservoir to the surface. Part of the CO2 gets sequestered into the reservoir. Part of it can be recycled from the facilities here, and it goes oil to the market. And that's how it should be, to make sure that we capture CO2 from the power plants. Now there is another aspect, so what is called the microbial UR, and microbial UR is again gaining an interest in the oil and gas industry, where the different types of organisms are being used to inject into the reservoir. So you can have microbes which are sustainable at reservoir condition, at high pressure, high temperature. These are called as thermophilic or barophilic bacteria, which can be used. And while they are injected, they are also injected with the nutrients. And these are generally done in the huff and puff method. So you inject those organisms along with the nutrients, then close the well, and then again reproduce the oil at the surface. There are other way to do that also. You can actually form these microbial cultures at the surface and in the reactor, bioreactor, and you generate biosurfactant which can be injected into the reservoir. These are another approach which are available. The other approach is more effective, because most of the organisms may not survive at the reservoir condition unless these are suitable to be survived at those conditions. So in this process, what they do is that they generate lot of bioproducts while they eat the oil as their energy resource. They form the acids, biomass, biosurfactant, gases, polymers, and solvents. All these bioproducts have a role to play in enhancing oil recovery. As mentioned here, the biosurfactant, they reduces this interfacial tension, so and so forth. Polymer provides a selective plugging and the viscosity reduction, etc., and so on and so forth, right? So some of these roles of the biosurfactant bioproducts of microbial, method provides enhanced oil recovery from the reservoir, and these are generally used in heavy oil reservoirs. So the MUR is generally classified not really always as a chemical UR methods, but it looks like similar way, because the byproducts are generally a chemicals, more of environment friendly, and therefore these are typically being used to recover more oil. Then there are types of organisms which are responsible to be used to be for UR applications. So there are aerobic, anaerobic, facultative, and there are mesophilic or thermophilic, and there are also barophilic bacteria which can survive at high pressure conditions, and thermophilic which can survive at high temperature conditions, right? So these type of organisms can be used for microbial UR. I will just take a 5-minute break, just have a water, or maybe 2 minutes break.
Sure, sir.
Okay, I'm back. So now there are more efforts which are also being looked at, that how we can improve the recovery by using advanced method such as nanoparticles, or you can use catalyst in situ along with the steam for heavy oil reservoirs, right? So these are also in situ combustion and so on and so forth which are being looked at. Now thermal UR methods, here we use a steam as a aid to improve the recovery. As the steam is being used, it provides a heat to the reservoir to decrease the viscosity of the heavy oil. So this is typically done in the hop and puff method. You inject and then soak it for some time, and then you again produce the oil from the reservoir. Right? So these are hop and puff methods which are being used. Now these steam injection methods are also being developed worldwide using some kind of solvents, so and so forth. Right? So there are some of the efforts which are happening. So there is another method which we talk about, steam flooding process, where steam is again injected from the injection well toward the production well, and in this process the hot water or steam is injected, and that impacts the viscosity of the heavy oil, and therefore it helps to push the heavy oil toward the production well. Because of the reduction in the viscosity. Yeah, another method which is called as in situ combustion, where the heavy oil, part of heavy oil is being burnt using the proper supply of air from the surface. Now the controlled burning is done. It's not that you burn everything. Controlled burning is done, and the gas that is being produced during the burning is help to push the oil to the production way. Also the heat that's also get burned, that also get produced due to the burning of the oil is used to reduce the viscosity of the oil, and then that help us to push toward the production way, and that's how it is being done. These are called the in situ combustion process. Now the various screening criteria are used for defining their applicability, particularly with respect to the oil gravity of the in terms of API, and we can see that all these methods are not competitive to each other. Though they compete at part of it, but they are have their own independent application for some kind of reservoir where other method may not be suitable. Now, the another area is the gas added as energy resources. We'll just briefly touch upon in 5 to 10 minutes. So hydrates are actually found to be useful for developing new technologies. Hydrate as a flow assurance problem is being there in the oil and gas industry, and a lot of research has been done earlier. However, in last few decades, it has been found that the uh, hydrate also shows a potential for energy resources, and therefore lot of research has been done to develop technologies for these resources for recovery. Hydrate can also be explored for CO2 sequestration, gas separation, desalination, etc. Natural gas storage and transportation, and so on and so forth. In India, we have a significant amount of hydrate reservoirs available in Andaman and KG Basin and Mahanadi Basin, and there are a lot of interest from the government of India to develop methods to recover this gas from these hydrate reservoirs. Now, in India, or if you look at the world map, you can see that the hydrate reservoirs are available across the world at different places. Uh, the presence of hydrate across the coastline is evident, all over the world. And if we try to recover this gas from these reservoirs, as on today's known reservoirs, we can supply several hundreds years of natural gas or energy requirement, and therefore it's have a lot of implications for for energy basket. Now, from how the hydrate forms, so hydrate can be formed from the biogenic way or thermogenic way. So in a biogenic way, the methane that is liberated from the organisms get accumulated in the form of hydrate, because here the temperatures are much low and pressures are much higher. So hydrate forms typically when you have a high pressure and low temperature conditions. In permafrost as well, where the temperatures are low, the hydrate formation is possible when the methane gas moves from the thermogenic seepage and get accumulated here, right? So this is all possibilities are there in a different ways, the methane gas accumulation in the form of hydrate. Now hydrates have been explored at a different location, and you can see that the how the hydrate looks like. It is ice like compound is mixed with the salt and clays, sand and clays, at different locations, and therefore it has a mixed morphology at a different location. So hydrate are primarily defined in the three major categories: structure 1, structure 2, and structure H, right? And here the different types of cages are being formed due to the water molecule at high pressure and low temperature conditions. Primarily methane or CO2 forms the structure 1 hydrate, right? Likewise. And here the water molecule forms the cages in which the gas get encapsulated at high pressure and low temperature conditions, right? And typically hydrate stores about 163 metric cube of gas in a 1 metric cube of hydrate, and therefore a lot of gas get accumulated in the hydrate cages, and therefore it has a potential, not only for as energy but also for natural gas storage possibilities. Now, when you talk about this recovery of hydrate,
அது என்னவா டைமிங் என்னவா எல்என்டினா ஃபர்ஸ்ட் என்ன எல்என்டில அவனுங்க ட்ரைனிங் மாதிரி கொடுக்குறாங்க போல எல்என்டினா லார்சன் அண்ட் டாக் ப்ரோ ஓ இன்டர்நேஷனலா அப்படிடா எல்என்டினா இதுடா இந்த சென்னையில மெட்ரோலாம் போட்டாங்கல ஆமா ஆமா
so when you talk about this hydrate phase diagram, one can see that
ஓ அப்படி இந்த பில்டிங் இது ஜெயின் இன்ஃபினி பார்ட்
mute them to mute.
இங்கதான் சொல்லி கொடுக்குறோம் பார்த்தா ரவுடி பைய பேர் இருக்கு
I'm trying to mute it.
Okay, so you have this phase diagram for hydrate, and you can see that this can be dissociated either increasing the temperature, which is also referred to as thermal stimulation. It can be dissociated by decreasing the pressure, which is also referred to as depression, and you can also dissociate them by using the chemicals like a chemical inhibition, right? So you can see that here this is a 0.8% of methanol, and you see this phase stability of hydrate curve. Left hand side represent the hydrate stable zone, and right hand side represents the hydrate unstable zone. So once you have this 10%, 10% methanol or 28% methanol, you can see that there is a clear shift of this stable curve towards the left hand side, right? And that way you can dissociate head rate. And there is another method where we talk about CO2 replacement, where you can inject the CO2 gas and push the methane molecule out of the hydrate cages and recover the methane. But there are challenges associated with the CO2 replacement, and a lot of research has to be done. So these are the schematic of how the different production methods looks like: depression, thermostimulation, inhibitor injection, and you have CO2 injection into the reservoir, right? So these methods can be utilized for recovery. I think I will skip this. Yeah, I think we can stop here. I think Dr. Fukan, uh, there are other topics which
Yes.
I think I can conclude, but I think that's enough, I guess. Okay.
No problem.
April 1 மேல தான் நான் அதை கூட சொன்னேன். April 1 மேல தான் நானே பிசி நான் துபாயில இருப்பேன். சரி ஓகே தான். ஓகே. அப்புறம் இங்க வந்தா இங்க இந்த ஒரிஜினல் தான் ஒன்று இந்த பாடி. என்ன ஹாஸ்பிட்டல்?
Thank you, sir, for the nice presentation. Any queries from the audience? If you have any queries, you can please type in the chat box also.
You also have this validity function now, right? What time
Yes,
is it?
it's around 5.
It's around 5 o'clock, right?
Yeah, we'll make it around 5, sir.
Okay. Yeah, because this is the last day, right?
Yeah, last is different. So if there is no query, give the remarks. On behalf of everyone present in this program, I want to thank Professor Jitendra Sangwai sir for his informative and interesting presentation on this important topic. So we thank and appreciate you for sharing with us your knowledge and expertise. I'm sure everyone liked your presentation. It was a pleasure listening to you, sir. Once again, from Dibrugarh University, thank you, sir, for accepting our invitation and speaking to us. Thank you so much, sir.
Okay, thank you so much.
So with this, we come to the end of all the 14 sessions of this FDP. So thank you everyone for attending and listening to the lectures. It was indeed great to have all of you during the 5 days attending and participating in this ATAL Academy sponsored FDP on recent trends in upstream petroleum technology that was organized by the Department of Petroleum Technology, Dibrugarh University. So at the outset of this valedictory function, I would once again like to express my deep sense of gratitude to ATAL Academy New Delhi for sponsoring and granting this FDP to Dibrugarh University. To all the resource persons, I am especially thankful for accepting our invitation and for speaking to us today, and also for sharing their knowledge and expertise on different topics about the upstream petroleum technology and the recent developments. My heartfelt thanks to all the participants for selecting and our university and this FDP. So without all of you, the FDP could not have been successfully conducted. I'm confident that you were benefited with good knowledge of the upstream petroleum processes and from all the deliberations that were happened in this program. So my sincere thanks to our Honorable Vice Chancellor sir for allowing us to organize this FDP. My special thanks goes to our HOD of our department, Professor Subrata Borgohaigogoi ma'am, for her advice and help throughout the process of organizing and conducting the program. Last not the least, I express my sincere thanks to my friends, colleagues, students, and the university as a whole who directly or indirectly helped me in organizing the program in a successful way. So if the participants have any feedback, they can speak up. Any feedback on the programs that we have conducted. Also, it can be typed in the chat box also. So thank you once again. I thank all of you for attending this FDP organized by the Department of Petroleum Technology. So now I will send you the online links for the feedback and also the online exam that has to be conducted. So I've already sent the link for the online exam. So you can try the exam till 9 in the evening. So after 9, the link will be disabled. So please appear for the exam. I have sent you the link on the emails. I'll send in the WhatsApp group also. And I'm also going to send you the link for feedback. Please give the feedback for today also. So thank you very much for attending this FDP and making it a success. Thank you once again.
Thank you, sir.
Thank you, sir. Thank you, sir. Very nice.
Thank you, sir. Very nice FTP, sir. Thank you, sir.
Thank you.
It was great experience with you, sir. Nice.